Hey guys, welcome to the session on Coffee with Prabh. And today we have a special guest, Mr. Siva Girishan. And I personally follow his content, what he writing. And recently he did a session in Black Hat also in Saudi Arabia. Unfortunately, I could not able to join. But when it come to Siva, he's working as security architect in one of the company in UAE and holding a credential which is dream to have everyone CISSP. I'm also CISSP, but now I'm jealous. This guy is OSCP. I'm not, and I will be his first student today who going to write a lot of notes. Along with that, he has CRTP, EWPTS, CCNA, Cyber Ops, and it was his interesting journey. He was doing active research on CVs, then he did a lot of assessments in past, and I thought, let us use this opportunity to have him in the podcast. And it's really honor for us to have him because he's going to discuss about the practical aspect of pen testing, AD, and all that, which can give a lot of insight to the our students and me also. And next podcast I will do with him where we're going to discuss about how to clear OSCP also. So thanks, Siva, and thanks for taking out the time in weekend. I know weekend is a family time, especially in Middle East. It's a time where the people, family demand your time, but taking out the time for us, giving back to the community, we really appreciate.
Thank you. Thank you so much for having me, Prabh. I'm very happy to be part of this session as well. I've been watching a lot of your videos. So being part of this actually, very happy as well. Thanks for having me.
Thank you. Thank you so much, Shiva, and thanks for inspiring me. So, Shiva, what is special today? What we are cooking? What we say
So
coffee with Prabh, but I think we have some biryani also.
Uh, so today's session, we would want to discuss about Active Directory security and penetration testing, right?
Hmm.
So Active Directory is one of the important aspects when it comes to penetration testing. So we'll try and understand a brief of what Active Directory is to begin with, and then we'll try to touch upon different areas of Active Directory testing. So we'll focus on primarily on the offensive aspect, but wherever necessary, we'll also talk on the defensive side on how to remediate it. So we'll, go through these aspects.
Definitely, and we are very excited for that, Shiva.
Okay, so I've just put together a quick deck just to guide us through the session as well. So to start off with this session, I just have a probably very simple question here. So let me just go back to the slide. Yeah. So I know that you wanted to cover something on Active Directory as well, right? So probably we'll start the session by understanding why Active Directory security is going to be important. I'll probably hand it over to you first to understand why you think this is very important, and then I'll share my thoughts as well.
So you want me to explain first AD?
Yeah,
Okay.
yeah, yeah.
Okay. So what I understood from the history perspective, when I say AD,
Mhm,
from the
mhm,
LDAP. Initially what happened, it was if you want to make the computer to be a member of a domain and all that,
mhm.
we adding a user accounts and all that. So it's very difficult to maintain the directory in every system.
Right.
So what we decided is we will have one centralized server where we can
Mhm.
keep all the accounts, and from any local system we can do the name lookup, and we can able to locate the user, and by which we
Right.
can able to
Right.
log in,
Mhm.
and that create a domain which is called as a domain environment, because we have a two type of network:
Mhm.
computer network, work group, and domain. And when it comes to AD, it can be a single point of failure also, because if AD is compromised, everything is compromised. AD itself is protected with the one admin username password. If that is brute force, you have access to all the user accounts. With the AD, we are enforcing with the help of Kerberos, which is offer the SSO authentication. And the biggest reason of using Kerberos because it do the ticket-based access without exposing a password over the network. And when it comes to Kerberos, we talking about golden ticket and silver ticket. The biggest concern for us, if hacker has access to golden ticket, because he compromising a Kerberos accounts, and through which he can able to generate a lot of silver tickets. So yeah, so AD is like one of the crown jewel we can say in the company,
Right.
because if and that's why we say the modern security start with identity security parameter. If you don't able to protect your identity, then it's gone.
Okay, so you left nothing for me to explain. So,
No, no, no.
so I completely agree with whatever you explained, right?
Hmm.
So, see, in security, we all know we will not be able to, prevent all the vulnerabilities out there. So there are going to be people who will be, clicking on phishing links. There are going to be some public-facing infrastructure that has vulnerabilities. So this is something that we are all aware of.
Hmm.
So, but Active Directory is going to be the place where it can massively explode. right?
Hmm.
So having one single server that is published on the internet, having some vulnerability and compromise is one thing, but that leading to the compromise of complete environment is going to be a different ballgame altogether.
Yep.
Similarly, when a simple phishing, a user is clicking on a phishing link, giving their credentials or downloading some malware, a laptop is compromised. But if that single laptop compromise can lead to the compromise of whole organization, that is where it becomes a lot more difficult. So what can cause that? Active Directory. So Active Directory is exactly in that place where if there are vulnerabilities in the Active Directory security, a single device compromise or a single identity compromise, as you explained, could lead to the complete organization compromise. And
Hmm.
that is why Active Directory, as you rightly pointed out, is very important as well. So with that said, why Active Directory security is slightly tricky as well. If you look at CVEs, for example, we do a lot of scans, we have vulnerability scans, and then have it identified. When
Yep.
it comes to Active Directory security, you either need to have specialized tools or manual assessments done for the vulnerabilities to be identified. It is not typically identified through your Nessus or Rapid7 for that matter. So that is where it gets a bit tricky as well. So we'll try and understand what are the different techniques that are applicable for Active Directory security and then the pen testing aspects.
Definitely.
So we'll start with some broad overview of what Active Directory, so that everybody will be able to understand.
Hmm.
And this session, anybody in security or IT should be able to understand it. So we'll have some basics covered, and then we'll go into the specifics of the testing techniques as well.
Definitely. And before we start,
And
Shiva, I
yeah.
need to understand one thing,
Mm-hmm.
and I want to make it very brutal.
Sure,
There's a
sure.
lot of aspiring professionals. They are now talking about AD pen testing. They're talking about
Mm-hmm.
lateral movement, Kerberoasting, and all that. Uh, those who just watching a video how to do pen testing on AD, is that
Mm-hmm.
worth,
Mm-hmm.
or they should know AD concept first? Because I've seen a lot of
Good.
people nowadays is Shiva is OECP. Definitely he crack OECP, but no one knows Shiva also did the basics.
Mm-hmm. Mm-hmm.
They see the outcome, but they don't see the process. So what is the one message you want to give to the people who watching this podcast and they came from a background of they about to start pen testing?
That's a very I would say insightful question as well. See, for me personally, when it comes to attacks, I would want to understand how the attack works, right?
Mm.
So I think that is where a lot of people slightly lack. So they have the specific commands that they know, they just run it and then compromise. But having an understanding of how the attack works is going to be very important. And along the same lines, you need to understand the technology as well. So when it
Mm.
comes to Active Directory, what are OUs, for example, or what are the some of the attributes that are really important. So understanding how Active Directory works, at least the things that are relevant to security, is absolutely important. So, without having this, yes, you will be able to, compromise the environments. But when you're put in a tricky spot where you need to have a solution in terms of security, it's going to be very difficult. So to
Okay.
answer your question, in this session also, we'll try and, cover how the attack works, where the vulnerability, lies, and sometimes we can even showcase the IT side of it. So if an administrator is there, what is the specific configuration is going to be vulnerable? So we'll cover those aspects as well. To answer your question in a very simple term, it's very important to understand the underlying technology components while you're trying to do the pen testing. It's the crux of what I would say is security is.
Excellent. Thank you. Thank you. Thank you, Shiva.
So let's jump into Active Directory. So, and
Hmm.
you gave a very uh, good example as well previously, right? So Active Directory, simply put, so let's say if you're working for a corporate and then you have your username and password, right? So if you use the same corporate username and password in your colleague's workstation or laptop, it is going to work. It is not like our personal laptops where the passwords are stored within the laptop or the device itself. So it
Hmm.
is going to be stored in a central location, so which is what we call directories. So when we talk about Active Directory, so there is going to be a database that exactly contains the list of users, the groups, their passwords, all the components or attributes related to the users and the organization is going to be stored in a central database, which is what we call as directory. So,
Okay.
and in technicality, in there's going to be a file literally called NTDS.dit that stores the entire information of the organization.
Okay.
So this is basically what directory is going to be,
Hmm. Okay.
right? So, and then we're going to have something called as directory services. So directory services is going to be like an executable or a service that helps us to interact with the database. So we established that directory is going to be a database that stores a lot of information. So directory service is going to be an executable or a service that basically helps us read the directory, update it, etc. So in our case of Windows, Active Directory Domain Services, or ADDS like people call it, is basically what the service aspect is going to be. So these two are the key components when it comes to Active Directory, wherein you're going to have the actual database, and then you're going to have a service that actually interacts with the database as well, right?
Excellent.
So, and lastly, when we talk about domain controller, so we all know that domain controller is one of the crown jewels in any organization. So domain controller is nothing but a server where this database is going to be stored. So the NTDS.dit file is exactly stored in the domain controller, and this directory service is going to be running. So a server, if it is going to be storing this database, and then it is going to be running the service. So this is what we exactly call as a domain controller. So this broadly summarizes, what the core components of Active Directory is going to be.
Okay. And
Right.
when it comes to the
So,
NTDS.dit, as you said, there's a lot of information is there. What are the detailed
right.
information we can see in this DIT?
I'll step through some of the information that we'll be able to
Okay,
see it
fine,
as well in a practical sense, like to
fine,
extract
fine,
NTDS.dit and do that as well.
fine.
So going back to the next aspect, LDAP. So we've talked about domain controller, a server that has the database, runs a service to be able to modify the database, right?
Hmm.
So for us to be able to access over network, that is where LDAP as a protocol is going to be coming into the picture.
Okay,
So LDAP, lightweight directory access protocol. So it provides a networked mechanism for us to be able to interact with this directory service and finally modify the actual directory database as well. So this is where all of the some of the vulnerabilities are also going to be coming into the picture, where you'll be able to modify certain things.
okay,
So with this said, now we are going to have a decent understanding of what directory is. So directory is basically the information that most of the organization related information in terms of users, your managers, contact, all these, including passwords, are going to be stored. Directory service is going to be an actual executable, and then you're going to have the domain controller. So the last part, basic information that we need to understand about Active Directory is going to be the structure itself, right?
okay.
So Active Directory, people talk about forest, domains, OU, trust, and all. So we'll try and understand what these aspects are going to be as well. So
Excellent.
for me to walk you through this instead of talking in the air, I'll take up a practical lab just to showcase, how this is going to be. So that's easier for people to visualize. So as I was mentioning earlier, so we have a lot of concepts when it comes to Active Directory in terms of domain, forest, OU,
Hmm.
etc. Right? So instead of talking about it in theory, I just have a practical, lab and setup which we can use. So first thing that I would want to point out is this lab called Game of Active Directory.
Hmm.
So this is an open source one that is prepared by a company called Orange Cyber Defense in France. So what they've did is they've built up a huge Active Directory environment for us to be able to play with it from security. So it has a lot of vulnerabilities in there. So we will be able to test our Active Directory security vulnerabilities in this, game of Active Directory. So anybody who's starting out in Active Directory security on pen testing, this is going to be a super valuable resource, because it's just a matter of running some scripts so that it'll automatically build all the VMs for us, and then we don't have to worry about the configuration aspect. So, and this is what we'll be using in this session as well. A huge shout out to the Orange Cyber Defense team to building such a massive lab out there.
Great.
So in here, if you look at this lab, so this is what we're going to be using here. So if we zoom in a little bit, so we have DC01. This is one of the domain controllers. So it is part of a domain called 7kingdoms.local.
Hmm.
And then we have another domain here called north.7kingdoms.local. So this is where the concept of forest comes into the picture, right? So in Active Directory, we have something called as forest, which defines the security boundary. We are going to have one domain, 7kingdoms.local. It can have multiple child domains. So this is going to be typically used in organizations where if they have multiple physical locations, I'm going to have a head office, and then I need to have domain controllers for individual remote offices. What they'll do is they'll probably have a location, domain controller for that specific location. And all of this is going to be forming a single forest. So in Active Directory, forest is going to be having a security boundary where you're going to have, a parent domain and multiple child domains. And there is going to be another domain here that is completely unrelated. For example, asos.local. So this is a completely different forest. Because if you look at that, it's 7kingdoms.local and has a child. And then we have a different domain here called asos.local. A lot of times what happens is when it comes to organization that goes through mergers. So I'm going to have my own, Active Directory environment, and then probably I'm going to be merging it to another organization, or I'm going to be having new subsidiaries. They're going to have their own Active Directory environment as well. And you may need to have some sort of, network level trust for users to access the services and resources across these domains. So this is when we explicitly enable trust between multiple forests as well.
Okay.
So forest is going to be your trust boundary, and then you can explicitly enable, trust between multiple forests as well wherever required.
Okay.
And then you're going to have domains, and then the child domains. So this is basically a higher level structure of how Active Directory is going to work. So you have forest, domains, and you can have intra-forest, trusts as well. And the last aspect is going to be on OU. So for us to be able to
Can you zoom it a little bit?
OU
Little bit zoom. Can you zoom
sure.
it? Yeah.
Sure.
Yeah.
So
Thank you.
if you look at this is 7kingdoms.local, which is one of the domain. And then we have a domain controller for this. And then we have few domain admins. And we have another domain, not.7kingdoms.local. So they basically, taken the theme of Game of Thrones and then built this environment.
Okay.
Yeah. So 7kingdoms.local, and then we have some servers here. So these two are part of a single forest. And then we have a totally different forest called asos.local and has a domain controller and a server. So this is basically the setup here. So going back to the last part of OU. So for us to understand OU, what I'll do is I'll actually log into this particular domain controller. So I have the lab setup. So we'll step through how does it look from an IT administrator point of view, right? So what are things that they're going to look at? Okay, great. So first off, I'll open command prompt. So King's Landing. So this is the server that we saw there. So King's Landing is going to be the domain controller for the 7 Kingdoms domain. So if I go to Active Directory users and groups, so this is basically the view, most of the domain administrators are going to be comfortable or, using on a day-to-day basis. So this is the domain in here. And then whatever is marked with a small icon here, these are OUs. So the idea behind OUs is if you're going to be grouping users or computers into specific OUs, we will be able to implement, security policies for this particular group. True. So it is going to be helping us to manage the Active Directory policies in a much better manner. True. So OU is basically a logical grouping.
Okay.
Right? So we have, crown lands as one OU, and then we have domain controllers, DOM. So we have multiple OUs here. And if I have to go to group policy objects, so when I have to, assign any sorts of policies, for example, we assign password policies, right? So this is the group policy management console where you'll be able to, create multiple policies. So if you look at here, you're going to have password policy. So the default domain, they've, configured some password policies. And similarly, if I have to create a specific policy for domain controller, I can assign it to the domain controller OU. So for us to be able to easily, modify or, assign policies, that is where OU is going to be helping us.
Okay.
Okay. So this broadly summarizes, the basic items that we need to understand about Active Directory so that we will be able to go into the security aspects of it.
Fine.
So far, I hope it's clear, right?
Yeah.
Okay, perfect. So now let's talk about some of the items that we discussed in theory. So remember you were asking about NTDS.dit. So this is a domain controller. If I go to C, Windows, and NTDS. So this is exactly the file. So all of the domain controllers are going to have a file called NTDS.dit, which is basically new technology directory services directory information tree. It's the name of the database, right? So this is where the complete list of users, passwords, groups, policies, everything is going to be stored. So this is basically our crown jewel. If I try to copy it, so I'm just trying to copy this into downloads, for example, it is not going to allow me. So when the domain controller is going to be running, they're going to be locking this file so that you will not be able to copy it. So since this is one of the sensitive files. So, but this copying or extracting of NTDS is one of the last steps, attackers do. Let's say if I've compromised the domain controller, compromised the domain, what they'll do is they'll try and extract this NTDS dot file, which is going to have the complete list of, users policies. So what we'll do, we'll use one of the mechanisms as well. So although it is, not possible directly for us to directly copy it, think of domain administrators. If they want to back up this file, there has to be a mechanism so that they'll be able to restore it. So that is what we're going to be using. So there is going to be a mechanism for us to back up this NTDS.dit file. So we'll use that as a mechanism to extract the NTDS.dit file out and see what are the contents that are there. Okay.
Okay.
So let me.
Can you zoom it a little bit?
Sure. Just 1 second. So let me just, you want the font size to be higher, right?
Just for clarity, yeah.
Sure. Yeah. Is it visible?
Yes, thank you.
Okay, great. So what I'll do is I'm going to be using a utility called NTDS utility. So which is basically to extract this. So I'm just gonna do it here. So what this is gonna do is currently, since the NTDS file is being processed, it will not be allowing us to copy it directly. But this utility is going to safely back up the NTDS.dit file, and then in this case is going to be storing it within the temp folder. So now if I go into the temp and NTDS, so we're going to have a copy of this NTDS.dit file. So now whatever information that is there that are our crown jewels, including users and passwords, we've extracted it. One thing to note about NTDS.dit file is it is, by default encrypted by a parameter called boot key. So every device, in Windows, be it servers or workstation, they're going to have something called boot key, which is unique to the device. They use that boot key to encrypt this NTDS.dit file. And this export utility, what it does is, it is also going to be extracting the system registry, which has the boot key. So that when we want to, decrypt it, we will be able to do that.
Okay.
Right? So basically, we've extracted the NTDS.dit file now. So now what I'll do is I'll just copy this to another, server, just to, showcase that we will be able to do it out of the server as well. I'll put it in my shared folder. Right. So this is what we were discussing in there. So right now what I've did is I've taken the NTDS.dit file from King's Landing server. Now I'll move it to the other server. So we have another domain controller called Miran, so which is DC03. I'll move to this server and then try and understand the files in there. So I'm going to go to the other DC. And if I open this now, I'm going to have this NTDS.dit file. I'll put it. So basically, I've extracted the NTDS from one of my DC and then moved it to a different server. Now we'll try and analyze the files, to see what are the information that is there. So let's start with some. First, I'll have to extract the boot key. Or shell. So there is a tool, suite called DS internals.
Okay.
So DS internals is the suite which is going to help us to, parse this NTDS.dit file and then show us the information that we want.
Okay.
Change the okay. So now I'm just going to go to NTDS and then I'm going to go into registry. So we have this system hive, so which is backed up from the other one. So what I'm going to do is I'm just going to extract. So I'm just going to be extracting. So this is going to be a script from the DS internals, so which I've already installed here. So it is going to be parsing the system to get the boot key out of it.
Okay.
So once I get the boot key out, I can go back to the NTDS.dit file now. And so there are multiple things that we will be able to see from this NTDS.dit file. So first basic item, what we were discussing so far is on the users list, right? So what I'm going to do is I'm going to be passing this NTDS.dit file and then look for a user called Cersei.Lannister and then try to extract the information of this particular user. So I'm trying to do it now. Since I'm doing it for the first time, it is saying that, you've copied it from a different OS and then we'll have to deconfigure it. And anybody who's going to be trying to, have this NTDS.dit file, one thing to notice, if I extract this NTDS.dit file from a particular build of Windows, I will be able to, parse it in the same build. So if I'm going to be taking an NTDS.dit from 2012 and I'm trying to open it in 2016, it won't work. So it has to be the exact build version. Only then it is going to work. So in this case, it is the exact build version. So I just have to defragment it and then it will work now. So now if I run the same command of Cersei.Lannister, so all these information are coming directly from this particular file now. So it has the username, it has the ID, and it has the primary group. And then the interesting information starts here. So the actual hash, NT hash of this user, which is what is stored in domain controller, is also going to be, visible for us. So it is not just for this user, for the entire set of users that are there within the complete domain. So this one single file, if compromised, basically means your whole organization's password is compromised.
Okay.
So
it's really you're making a fear-based podcast now.
So a lot of times what attackers do, as I was explaining, is once they compromise the domain controller, this is what they go into. So they extract the NTDS.dit file and then the SAM key, and then they go into the dark web and start publishing it. Because since just one file has the complete information of the organization, it is going to be extremely sensitive. So let's try and understand some more information. So what I'll do is, so we'll also be able to list all the users and the corresponding hashes. So these are the complete list of users that are there in this domain. Since it's a testing one, this is the complete list, and then the corresponding hashes are also going to be there. So as you were mentioning before, we also have KRBTGT here. So we'll come to this in a while, but this is again one of the most critical passwords, as you know, on the Active Directory. So we'll come to this in a minute. I'll talk about one last thing in this before I go into the next one. So this is trust. So remember how we were talking about what forest is going to be, how domains are set up. So in terms of domains, I was explaining about trust, which is also going to be stored in the same file. So anything about the domain is going to be stored in that file. If you look at this, we're talking about the domain 7kingdoms.local, whose trust partner here is north.7kingdoms.local, which is basically its child domain. And we have bidirectional trust. And similarly, if you look at the other one, we have 7kingdoms.local here. And then the trust is a source.local, which is a completely different forest, and which is what is explained here. So anything and everything about the domain is going to be basically stored within the NTDS.dit file, and then we'll be able to parse it and extract it.
Okay.
Right.
This is
So
excellent.
now, thank you. So now we have a comprehensive understanding of how critical NTDS.dit file is, what are the information that it actually stores, and then what Active Directory broadly is going to be, right? So now we'll take a step back and go back to what are the attacks or techniques that we'll be able to look at, right? So I'll just go back to my slide again. I'm gonna be sharing my slide. Just 1 second. Yep. So now we have as I was explaining, we have a clear overview of what Active Directory is going to be. It is a central place. Everything is going to be stored, and then all the users are going to be, using this. It stores all of the critical information, including passwords, etc. And we talked about forest domain trust. So now let's go into Active Directory pen testing, right? So that is what we wanted to cover.
Yeah.
So Active Directory pen testing is, usually comes in the slightly later stage. So it comes in if a user has already been compromised, if a server is already compromised. So some sort of initial access has been established in the environment. So how can I escalate the privileges more? So how can I, change a single server compromise into a complete organization-wide compromise? So this is where typically Active Directory, pen testing is going to be coming into the picture. So these are broadly the 4 stages. One is wherein nobody has, no access is there. It could be through phishing, etc. And then some sort of initial access, which is where Active Directory is relevant. And then we're going to have domain escalation, and then we're going to have domain persistence. Right?
And we're going to see practically every entire process.
Yes. So we'll try and have at least couple of scenarios across all these aspects, so that we'll be able to demonstrate those as well. So if you look at no access to low privilege, this is something all of us in security know, right? So if we don't have any sorts of access into the environment, phishing is one of the common ways. Exploitation of public infrastructure is one of the common ways. So this is where you go from no access to some sort of low privileged access. The other aspect is on SAM dumping. So this is for physical access. Let's say you have an organization where a lot of people come in and have physical access to the laptops or workstations. So what they usually do is, this is again a very old technique. So just like how we talked about NTDS.dit file in domain controller, every computer out there in Windows is going to have something called a SAM file. So SAM file is going to be storing the passwords of the machines, right? So if we don't have BitLocker in my workstation, it is just a matter of extracting that SAM file and then getting the password. So this is a extremely old technique. So I think
and BitLocker is used to encrypt your entire system.
Exactly. So BitLocker is going to be encrypting your whole file system, so that people will not be able to access it, right? So this is extremely old technique, but if BitLocker is not enabled, it is still possible. So that is if somebody has physical access. And then last aspect, these 3 are if someone has some level of network access to your environment, right? So they don't have a user account, but they were able to bypass NAC, for example. So they have a physical access to their environment, and they want to have initial access. So these are the common things that people do. Password spraying. So I take one simple password and spray across all of the users to see if any of the users are using this password. And we'll talk about LLMNR poisoning and a bit on SMB relay as well. So
excellent.
LLMNR poisoning is one of the common things that every pen tester does if they have a network level access. So we'll try and demonstrate what this as well. So moving on, there is going to be a lot of techniques that are on domain privilege escalation. So if I have a normal user access in an environment, what are the various things that I will be able to do to get to domain administrator? And lastly, if I have compromised the domain, how can I have persistence in the environment? So which is where the golden ticket is going to come into the picture. So whatever is marked in bold, we'll try and cover all those aspects as a part of this discussion.
Okay.
Yeah. So let's step into LLMNR poisoning. And this is the gambit of things that I'm hoping to cover as a part of this session. It's a lot. So, as time permits, we'll see, how many of the items we'll be able to cover, right?
We have an entire day.
So
Just kidding. Yeah.
this this starts from having no access in the environment and having some level of network access all the way until the golden ticket. So these are the different things that we'll try and cover. So starting with LLMNR poisoning, right? So LLMNR poisoning is, LLMNR, it stands for linked local multicast name resolution. It seems complex, but it's, pretty simple. So what it does is, in terms of active directory environment, if I have a name, usually you're going to have a DNS server to resolve the IP address.
True.
So that is the whole point of DNS server, right? In environments where DNS servers are not there, they have a mechanism just to shout and see if anybody knows the IP address. So this is exactly what LLMNR is. If you're in an environment where DNS server is not there, but there is a server and he knows its name. So what this LLMNR will do is, it is just going to shout and see if anybody knows the name, and then it is going to talk to them. So this is at a very summary what LLMNR is. Let's step through how this attack specifically going to happen. So if somebody is in a laptop or a workstation and is trying to access a file server, and assume that they have a typo in it, instead of file server 01, I've just added another E. Okay, so it is going to go and ask the DNS server what is the IP address. Since there is a typo, the DNS server is not going to know what the server is, right?
Okay.
So it is a server that it doesn't know. So this is where LLMNR is going to come into the picture.
Okay.
By default, Windows, what they do is, if they don't know the IP address of a particular name, they have a functionality to broadcast to everybody in the same network and ask for the particular IP address. So, which is what LLMNR as a protocol is going to be. So, in this case, what I'll do is, I'll go to everybody in the 1.0, subnet, and ask if anybody knows the IP address of file server with the typo. So, and if there is an attacker in the environment, what he will be able to do is, he'll be able to sniff for these traffic. Since it's a broadcast, he's going to be receiving it. So he's gonna, listen for these traffic, and then he's gonna respond saying that he's the corresponding person. So he's asking for file server. The Kali Linux here is going to be saying that file server is my IP address. So this user, although it is a typo, he's made to believe that this server exists in this environment and the IP address is this. So now what the device is going to do is, since it's a file server, it's going to try and access the file server, but is going to be connecting to the attacker's machine, and attacker is going to be asking the user to authenticate like any other file server, and the user is going to be giving his authentication details. So this is basically how an LLMNR poisoning is going to work.
Excellent. And
Right?
I think I think for me also it's a new word, to be frank. That's why I made a note. Yeah, that's my next research, which I'm going to do.
So LLMNR poisoning, it is for pseudo DNS. So in environments where DNS doesn't exist, it's just going to broadcast. But since there is no authentication or trust here, I'm just believing whatever anybody says. So an attacker is just going to tell his IP address is the server's IP address, and then the device is going to be communicating. So this is essentially what LLMNR poisoning is. In this process, what is going to happen? We're going to be having the NTLM response captured by the attacker, and then we will be able to crack it.
Okay.
So now that we have an understanding of what LLMNR is and how the attack works, let's try and demonstrate the same thing. So let's go to our lab and see how this is going to actually work. So this is one of the servers where I'm going to be trying to simulate the typo here. So I am logged in as a user called Carl Drogo. So this is the user who's going to try and access a file server, and then I also have my Kali machine on the
Kali is one of the
same
favorite
subnet.
machine we had. We called Backtrack once upon a time.
Yeah. I think I've used that as well. So Backtrack, and then it changed to Kali.
I started with Backtrack only 2006.
Oh my God! Wow. Okay. That's interesting.
Then they made it more better and optimized. Yeah.
Yeah, that's true. So I think now, there are, although we use Kali a lot, now a lot of tools are ported for Windows. For example, Active Directory, it is much more comfortable to work in Windows than in Kali. So, but Kali, I think the wallpaper gives a lot of, happiness to a
Appeal.
lot of people as well. Yeah.
Yeah.
So now that we understood the concept of
I
LLMNR,
thought it was
so let's
inspired
talk.
from India. We called it the Kali Ma.
Yeah,
We have Kali goddess, right? So
yeah.
that basically give that perspective. Yeah.
That's true. I remember, similar aspect when I was talking
Hmm.
about Kali or phone while I was in, house and all. They're like, what Kali? Like, no, it's a different Kali altogether. So going back, we have a tool called, responder. So, so what this tool does is, if, based on understanding, it is going to be doing two things. One is it is going to be looking for these protocols. For example, LLMNR is one of the protocols that we talked about. So it is going to be listening for this message to see if something is going to be received, and in addition to that, it is also going to be setting up the SMB server. So if
Okay.
somebody is trying to access the file server, it is going to be having a server so that it can ask for authentication. So this is basically the purpose of the responder tool. It is going to listen for LLMNR and then send back a poisoned response, and then it is going to be having an SMB server so that it can receive the authentication as well.
Hmm.
So now I've started this responder in my Kali machine, and what I'll do is I'll go back to my other Windows machine, and then I'm gonna say file srv01, right?
Hmm.
I know that this doesn't exist in my domain, so I'm just gonna try and access this. So it is coming back and saying that access is denied.
Hmm.
So if you look in the background here, so this is what is going to happen. So it has received a request and then it has sent a response to this IP address. So this is going to be our server IP. And then it has received a hash here for this particular user, right?
Hmm.
So this is what LLMNR poisoning is. So if you see here, this is the name. So somebody has just came and asked me if I know this, even though I did not actually know. I've just said that that is my IP address. I've asked them to share the authentication details. So now this hash that is in here is called, it is NTLM v2. In actuality, it is called net NTLM. And this hash is something that we will not be able to use for pass the hash,
Hmm.
right? So we talked about another hash before, so that we looked at in the NTDS.dit, which is called NT hash. So NT hash is the hash. If you have that, you don't have to crack it. You can just pass the hash, and then you'll be able to get access. So that is the directly derived from the password. However, in this case, what we are looking at is going to be an authentication protocol. So net NTLM is an authentication protocol. So this is not something that I'll be able to directly pass. I'll have to crack this hash to use it.
Hmm.
Okay. So probably I'll just take this is one of the commonly uh, misunderstood item as well. So we'll just talk about hashes for a couple of minutes and then we'll go back. So we had LM hash or LAN manager hash, which is the oldest one. So XP and before used to use this. So which is again the actual password. So so password is going to be hashed and then stored as LM. So this is one. And then later on we had something called as NT hash. So
Yeah.
people usually call it NTLM. This is actually NT hash. So we no longer use the LM part.
Hmm.
So these two hashes are something that we can use for pass the hash.
Hmm.
What we received right now is going to be on the authentication protocol. So which is called net NTLM. What we have is NTLM v2. Earlier version is going to be v1 as well. So we're going to be getting these hashes, but this is going to be something used as an authentication protocol and needs to be cracked before we can do something about it.
Hmm.
Okay. So these are the different types of hashes that we have. So now since I have this, I can try and crack this hash. So what I'll do, I'll just see if I have any hash file I'll remove it. And I'm gonna paste this hash here, right? So when it comes to hash cracking, the tool that we generally use nowadays is Hashcat because it uses GPU, and then it is far more better than using CPU based cracking. So when it comes to cracking, GPU always wins. But since I'm using a VM here, I'm going to be sticking to the CPU, and then I'm going to use an older tool called John. So I'm sure
John
that
the
you'd have
Ripper?
heard of. Yes.
He ripped a lot of
So
passwords.
so I'm going to be using John the Ripper, and I'm going to pass this hash, and then I'm going to again use our classic, password list called RockQ. So I'm going to be using this here, rockq.txt, and I'm going to be running this hash. And in this case, what is configured is an extremely simple password called a horse. And then I got the password immediately. So when it comes to LLMNR poisoning, what we're going to do is we're going to extract the net NTLM hashes
Ashes.
and then try to crack it. And then in this case, it is successful for us to crack, right? So horse is basically the password. So now we have initial access to the environment. So now I have a username and a password in the Active Directory environment, which I can use further, right? So when it comes to hashing, one of the things that even I struggled early on is what password list do I use? Right. So RockQ is going to be good when it comes to things like hack the box, etc. RockQ is going to be very useful. But when it comes to real world environments, RockQ is not something that is going to be helpful. So that is a tricky spot. Everybody tries to address. If we look at the actual password lists that are going to be useful in environment, practical scenarios when we are doing pen testing. So earlier I used to rely on something called as CrackStation. So CrackStation had a huge dump, that was made available. So now there are two items. So there is a site called WeakPass. So I'll have to stop and share again. Just 1 second. So this is a site which makes publicly available passwords for us to be able to crack. And then if you look at the volume of the passwords that are there, in this case is 2.19 billion. So when we try and understand what sort of word list that is out there to use in practical pen test scenarios, WeakPass is going to be one of the things that we can use. And a lot of times what we do is we also customize the passwords. So we take the organization's name and have some rules run on top of it. And then we're going to be creating custom word lists, which is a lot of times more successful. So this is something, that we generally use when it comes to the password cracking. So in our example, I used, RockQ, but these are some practical examples that we can use. And I'm going to be also sharing one of the tricks that at least people in my surrounding was not aware of. So when it comes to cracking this NTLM, a lot of times we rely on these kind of password lists, which is really helpful. But complex passwords are not something they will be able to crack. So they're going to be cracking common passwords and things like that. That is what they're going to be usually doing. But there is a mechanism in which we will be able to crack complex password as well. And this is one of the things that a lot of times people are not aware of. Just showcase what I'm trying to do. Just 1 second here. So even as a concept, this is going to be slightly interesting. So what we're doing is, in the case of net NTLM v1, right? So or v2 in the case, we are trying to make it into a actual clear text password. So this is what we are trying to do in cracking, right? So we take a hash and then we crack it, and then you're going to have a clear text password. What if I take a hash, in this case net NTLM v2, and then crack it into a NT hash? I'm taking a hash and then I'm going to be getting another hash as well. So maybe there are two questions. Why would I want to do it? So that is going to be first question. And then what is going to be the benefit? So these are some, two questions that we need to answer. When we talk about this, we have lists like WeakPass, which is going to be helpful for us, but it is not going to be containing actual passwords that have been used by users. But what if I can look at actual passwords that have been compromised for the users and then use it in terms of my pen testing engagements. So this is where things like Have I Been Pawned is going to be helpful.
Yeah.
So Have I Been Pawned is going to be a website that contains all of the passwords from known breaches, but they don't give out clear text passwords intentionally, because passwords can contain sometimes personal information. All these information are going to be available, so they don't provide us with clear text password. But what they do provide is they provide us with NT hashes for all the compromised passwords. So even if for example, I'm going to be having a complex password which Siva at some special characters, blah, blah, blah. But this password was compromised in any of the previous breaches. This is also something that I can use in my password cracking. So I'm going to be getting an NTLM, but now I'm going to be having extremely good coverage, even in terms of previously, compromised password, which are complex too. And then I'll be able to, crack it. So this is not usually, aware by a lot of pen testers as well. So because when they try and crack NTLM, they try to crack with clear text, but you will also be able to use the NTLM and crack it to NT hash and then start using it for pass the hashes. So this is supported by Hashcat. We'll quickly, have a practical example of how this is going to be possible. So again, we'll have to switch. So this is only supported in Hashcat. This is not supported in John the Ripper, unfortunately, as of now. So I'll go back to my Windows machine where my Hashcat is. So this is the trick that I was referring to earlier, where even a lot of pen testers are not aware of. So they are aware of having the hash cracked into a clear text, but cracking the hash into another NT hash which can be passed is something not a lot of people are aware of. So what we'll do is we're going to have the actual hash which we just got there. So this is going to be hash.text. So this is the hash that we cracked. And what I'm going to do is I'm going to be cracking this with the hashes again. So usually when it comes to word list, we're going to have clear text, right? But in this case, my word list is also going to be hashes. So I'm cracking an NTLM hash, which cannot be passed using pass the hash to another hash, which is going to be used for pass the hash. So why am I doing this? NT hashes, we have a huge list of NT hashes that is publicly available with complex passwords as well, which I can use in actual pen test engagements, which is going to have a much higher cracking rate. So what we'll do is I'm just going to be running the Hashcat now. So this is going to be right. So I'm going to be using Hashcat. So this particular technique is called has the ID of 2700, wherein it is going to be taking the net NTLM v1 hash, v2 hash, and then getting the NT hash out of it. So I passed my hash text file and then the rocky with NTLM. So if I run this now, so it is going to take some time since it's going to be a bigger file. It was quick this time. So if you look at the response, there is not going to be any clear text, but this one here is going to be the NT hash now, which I can use for pass the hashes. So even in scenarios where you're dealing with complex passwords, which cannot be, cracked through clear text, I'm going to be able to use the NT hashes from Have I Been Pawned, which has real complex password that has been compromised earlier, and then use it for pen testing engagements.
Okay.
So this broadly, summarizes what we wanted to look in terms of the hash cracking and LLMNR poisoning.
So by this, we got the password of the AD, right?
Yes. So we have cracked a user's password called Carl Drogo. We have his password, which is harsh, and then we have the corresponding hash as well. So now we have initial access to the Active Directory environment. So now it's like we've either compromised the user through phishing or we've compromised the server where some sort of initial access with low privileges are there. So now what else can we do in Active Directory?
Yeah.
So that is what we're going to do. Look next.
Okay.
Yeah. Just 1 second.
But it's really a good insights, and you've given me a lot of tasks, buddy.
Glad it's helpful, Prabh.
Yeah.
So I'll go back to my slide just to see, what we've discussed so far. So we've talked about LLMNR poisoning. So again,
Hmm.
this is one of the common techniques that are used by any pen testers, from an Intel engagement. So how can we address LLMNR poisoning? Simple answer: disable it.
Hmm.
None of the modern Active Directory environments that we are using right now needs LLMNR. So we're going to have the names stored within the DNS. So disabling LLMNR, MDNS, and these protocols is going to be the safest way, and it is not required for us. And the other aspect is going to be password hygiene. So as long as we are covering both these aspects, LLMNR poisoning is something that we don't have to worry about.
Okay.
Right. So we've talked about LLMNR poisoning. We've talked about hash cracking two techniques, one to clear text, the other one to anti hash. So now let's talk about BloodHound. So BloodHound is a tool that we will have to talk about when we talk about Active Directory security or pen testing. So let's go back to our Kali now. So what I'll do is I'll just, take the information, whatever we've got so far, so that we have a better place to track. So we've got this hash, right? So we've got this hash, so which is part of the domain called ASOS. Probably copy the whole thing. So we know that there is a domain called ASOS, and then there is a user called Caldrogo, and
Hmm.
then we've also compromised this user's password, which is harsh. So this is the information that we have so far. So how do we progress from here? So one of the things that we need to know next is what is going to be the domain controller in the environment, what are the servers in there, so that we will be able to proceed
Or we
further.
can have a lateral
And,
movement
and
also.
exactly, so that we will be able to laterally move in the environment. So what I'm going to do is I'm just going to do a simple nmap scan of this particular subnet for top ports. Yes. So I'm going to be doing a simple nmap for top 100 ports for the subnet that I'm part of to enumerate the versions and run nmap scripts as well. So what this is going to tell me is what are the servers obviously there in the environment. And this is also going to help me understand if there is going to be any domain controllers in this particular subnet or not.
Hmm.
So let's just give it a couple minutes for it to complete. So the way we identify whether it is a domain controller or not, from a network perspective, are based on a couple of ports. So if we see a DNS service running, okay, the results are here. So if there is a DNS service that is running, so this is a initial indicator, and the confident indicator is going to be on port 88. So if there's going to be a Kerberos service running, and if there is an LDAP service running, so if you see these three services running in a server, right? So DNS and LDAP and Kerberos, most likely it is going to be a domain controller. And then you're going to have the details on the domain as well. So this
Hmm.
one is 7kingdoms.local. So we have one IP address here. Just make a note. So this is 7kingdoms.local. Most likely seems to be the domain controller of this. And then going back, what other IP addresses? We have another IP address 192.168.50.12. So which again has DNS service, Kerberos service, and LDAP as well. Excuse me. So and LDAP as well. And this is part of the domain sos.local. So if you remember, this is the domain that we had the user compromised as well. So 192.168.58.12, which is sos.local, seems to be the domain controller. Again, this seems to be the domain controller. And we have any other IP address. So we have an IP address 192.168.58.23, which does not have DNS or Kerberos or LDAP. So this is most likely not a domain controller, but it has a SQL service. So we have got 3 IP addresses. 58, what was the IP again? 23. So 23, and this is also part of source.local domain. And this doesn't seem to be like a domain controller, right? So let's try and understand if we have any other information from this, like host names, etc. So if you look at the entries, so here it's not there. It's going to be usually as a part of, LDAP. So here it says that it is King's Landing
local.
Yes. So King's Landing is going to be the most likely the host name of this. And anything else? Here it's Miran. And last one, 58.23. Yeah. So DNS company name is Bravos. Right. So now we have, 3 servers in the environment that we just did the scan on. So one is related to a different domain, which we don't have any information on. So there are 2 servers, miran.esos.local and bravos.esos.local, one of which is going to be the domain controller.
Okay.
So now we have a user account, right? So we have a user account. So now we have a user account called Kalradrogo that is part of the domain esos.local. We know what is going to be the domain controller. So we have basic information on the domain and an initial access so that we will be able to go ahead and start doing enumeration. So once we have this, now any user in the domain will be able to list down all the other users. So, and they will be able to list down all the other groups. So there's going to be a lot of information that a normal domain user will be able to retrieve from a domain. So this is what we're going to be doing. There are manual ways to do it. In Windows environments, we have tools like PowerView, so based on PowerShell, so which is going to be the manual approach. So in this case, we're going to do a automated approach using BloodHound. So I'm going to be running a BloodHound script to extract all these information and then show it to me in a nicer format.
Okay.
So this is what we're going to do next. So what I'll do is BloodHound. So BloodHound has 2 aspects. So one is going to be a collector. So collector is basically a script. What it does is it is going to go to the domain servers and then collect the information. So that is the collector. And then there is going to be another setup which is going to be visualizing it. So first I'm going to be running the collector. So okay, I have the command already. So BloodHound Python. So what are the things that I need to collect? I'm just going to say collect everything. And what is the domain that we are talking about? It's esos.local. So I have the user as Carl.drogo and the password is horse. So the DNS server in our case is going to be the IP address of the domain controller. And zip is basically, it is going to be spitting out a lot of files. I just want it in one single file. So I'm going to be running this, but before I run, I'll just go to, I'll just go to a folder and then I'll run it here. So I'm just going to be running it here. So now it is going to go to the domain controller, extract all the information, and then spit it out in a file, which we can later parse. So it says that it has found one domain, it has found 2 computers, so many users, groups, etc. And now I have a zip file containing all this information. So now I have to run the BloodHound's, front end to be able to parse this information. So it is something called Neo4j. So Neo4j is basically the database. It is a graph-based database that is going to help us, in terms of visualization. So I'm just going to start this. So Neo4j, I'm going to start this server. And what I'll also have to do is I'm going to be starting the BloodHound. So I have BloodHound already installed. So this is going to be the visual engine of BloodHound.
Hmm.
So what I'll do is I'm just going to clear whatever is in here so that we can start looking at from the fresh. I'm going to clear the database. So if you've set up BloodHound, this is the empty screen that you're going to have. So what I need to do is I need to upload the data that I just extracted. So if I go to home and BloodHound output, so this is the file that it spit out based on the script that I ran. So I'm just going to be importing this file. So it is going to have groups information, computers, OUs, domains, CPOs, users. So all the information that is extracted is now loaded into this visual. So now we can start analyzing the domain from a visual manner. So for example, it is just a click of button. So if I click on, this is find all domains. If I click on find all domains, domain admins, what it'll do is it is just going to be telling me, okay, administrator is one of the domain admins in this environment. Just 1 second. I know it's a bit small. I'll try to zoom in. So when I click on find all domains, this is the output that I get. So this is the domain administrators group. And currently there are 2 users directly in the domain administrators group. And there is another group in here, which contains another group and then has another user. So when we talk about users, we have 3 domain administrators currently in this domain. So first one is called Daenerys Targaryen, which is one of the domain administrator. And then the other one is the default domain administrator. And lastly, we have a user called Drogon. So in my environment, right now I have 3 domain administrators. Similarly, I can map a lot of other information as well. What we were looking at NTDS.dit. So I have 7kingdoms.local, which is trusted by easters.local. So all the information about the domain is something that we will be able to analyze at the click of the button. So what are the computers with unsupported operating system? Currently, we don't have anything like that. So we can go into, each of these steps, but what I'll do is I'll take a step back now. So what we did, we've extracted the information about the domain, right? Now we know that we have compromised one user, which is Khal Drogo, right?
But it's not a privileged user, right?
Yes. So that is something we don't know yet, which is what exactly we're going to look at. So Khal.Drogo. So I can just click, search for this user, and then this user is visible. So we can start understanding what is the privilege of this user, which groups he's a part of. So all these are some items that I can do visually using this tool. So if you look at Khal.Drogo, we have the user's object ID. Let's talk about groups, right? So first degree group membership. So he's part of 2 groups. One is called Dothraki, and the other one is domain users. So this is the usual, group, domain users, the default one. And then there is another one called Dothraki. So the biggest advantage of BloodHound is that you will be able to have these graphs run on a recursive manner. So right now it is saying that this user is part of these 2 groups, right? So if I want to know which group this is part of, I can just say unroll membership, and then it is going to analyze. So it is going to be storing the complete graph of information so that it can, link between things. So from this point to this point, if I have to see if there is an attack path, it will be helping us with this. So that is why, BloodHound is one of the famous or even favorite tools for everybody. So in this case,
even today also, everyone is using that.
That's true. So this is again maintained by a company called Spectrops. They're doing a amazing job on the Active Directory and identity security. So,
and guys, this is not any paid video and all that. We're just sharing the information which we believe can be important for you guys. Yeah.
Agreed. So all these are again open source, readily available for everyone for them to use as well, right? So going down, there is also the local admin privileges. So if I just click on this, so it says that this user is having local admin privileges on this particular server as well. So Like these, we will be able to try and understand what are all the different privileges available for the user. Now, in terms of local administrators, the common aspect is two items. One, we discussed about SAM database a little while right back. So SAM database one that is going to be containing the passwords within the device. And the thing is, any local administrator of a particular server or workstation will be able to access the SAM database and then retrieve the passwords with it. So that is something we will try now and showcase it. And the other aspect of local administrator is the common usage of Mimikatz. So if I am a local administrator on a particular device, and at that device, if a domain administrator is logged in, what I'll be able to do is I'll be able to run Mimikatz, dump a process called LSAS, and then I'll be able to retrieve his passwords as well. So these are the two items that are commonly used in terms of local administrator privileges, which can, give us with domain escalation.
Okay.
So we'll look at the first step. So we know that this guy is a local admin to Bravos. And if we go back to our list, Bravos server IP address is going to be this. So what I'm going to do is I'm going to be remotely dumping the SAM database of this particular server. Since I have local admin privileges, it should work. So let's go back to our CLI. I want to stop this. I want to stop this as well. So there is a tool called secrets dump, which is part of the in-package suite. So what I'll do is I'll just pull up the command for this. Right? So the tool is called secrets dump. So what it is going to do, it is going to be remotely logging in to this particular IP address with the username Drogo and the password horse, which belongs to the domain source, and then retrieve the hashes that is stored within the SAM database. If I have local admin privileges on this particular IP address, which is what BloodHound is saying, I should be able to dump these passwords.
Okay.
So let's try this out. And as you can see, the local user accounts that are stored in the particular server's IP address is listed here. So we have an administrator account, we have guest, default, vagrant, etc. And the NT hashes of these particular user accounts are going to be extracted.
This is brutal.
It is so this is going to be the SAM database again. If you see, dumping local SAM hashes, and similar to what we discussed earlier, even the SAM database itself is going to be encrypted with the same boot key. So what it does is it goes to the registry first, extracts the boot key, and then extract the SAM and decrypts it, and then shows us the information that is stored within the SAM database. So we have some local administrator accounts and then some cache credentials. So these are usually much harder to crack. And what else? We also have some service account privileges here. So we'll come to this in a minute. So right now I have local administrator, which I already have. So I just don't want to, copy this again. So this is the only information that is new and interesting for me. So I'm just gonna make a note of it. So when it comes to local administrators, if I'm part of a local administrator group on any of the servers, what I can do immediately, I will be able to dump the SAM database, and then I'll be able to extract all of the local user account credentials. That is one that we'll be able to do. And at that time, if any of higher plus users are there, for example, when the time I'm trying to dump the hashes from LSAS. So there are two aspects. One is SAM, which is on the local password, and then there's going to be a process called LSAS. So LSAS process is going to be storing the user's hashes as well, even if they're just logged in. So for example, if domain administrator is logged into the server and I'm trying to dump the password from LSAS as a process, then I'm going to immediately be getting the domain administrator's hash as well. And this is where the tool Mimikatz is, commonly used for and got famous for. And I think Mimikatz as a tool has been there around 10, 15 years now. So LSAS is a process currently is the most protected process in any Windows environment for the same reason. So, anybody who's touching the LSAS process are heavily monitored, but we still have, bypasses and different mechanisms to be able to extract it. So this is how local privilege escalation is going to be helping us in obtaining domain privilege escalation by dumping passwords and credentials, right? So is there a way we can mitigate this? Answer is going to be yes, basically by limiting who we are giving local privileges to. We are at local privilege escalation now. So the only way where we'll be able to, reduce this broadly is don't give local privileges to everybody. So it is going to be only to the limited set of people. And when it comes to LSAS specifically, so there are techniques or, solutions called Credential Guard, which is natively supported in Windows. So if you're going to be enabling Credential Guard, then LSAS process dumping is not going to work. So these are some of the common ways in which we will be able to prevent. And the last important thing is Windows has, a mechanism called tiering. So tiering is one of the most important security mechanisms that we need to follow in Active Directory. What it basically means is if you're a domain administrator, you should be logging in only to these tier 0 assets. So when we say tier 0 assets, it's going to be domain controllers, Active Directory certificate services. So only these set of servers you will be logging into. You should not be logging into any laptops, end user laptops or servers for the same reason. If there is a malware running on that server, then the domain admin credentials is going to be immediately compromised. So this is the reason why, Windows recommends something called as tiering, where tier 0 is going to be domain administrators, domain controllers, etc. And then we have something called tier 1, which is going to be for server administrators, and tier 2 is going to be for end users. So this is a mechanism that, Microsoft recommends. And this is how you will be able to address on the local privilege escalation and, dumping of passwords. So now we'll go into the next step on Active Directory certificate services. So now that we covered the first row of things, we talked about LLMNR poisoning, hash cracking, BloodHound as an overview, and local privilege escalation, right? So the next aspect is on Active Directory certificate service. And Active Directory certificate service is something that has gotten recently popular. When I say recently, it's been around 4 or 5 years now. And a lot of adversaries have started abusing this in an extraordinary manner. So the problem with this method is some of the vulnerabilities in Active Directory certificate services, if it's introduced in your environment, somebody will be able to compromise your whole domain in less than 5 minutes. I come into your environment, I have a local privileged account in your environment. All it takes is going to be just 5 minutes to get to the domain administrator. That is how bad, Active Directory certificate services related vulnerabilities are. So let's, cover some of the items on this vulnerabilities. So before I jump into that, I would want to, refer the actual resource for this. Just give me a minute here. Yeah. So let me share my other screen. Yep. So this is when, things got popular for Active Directory certificate services. So there is a detailed paper called Certified and Pre-Warned. I think this got published in 2021, if I'm not wrong. And yeah, it's 2021. Yeah. So it got published in 2021. And this detailed, a lot of attack techniques that is going to be possible for Active Directory certificate services. So it goes on from ESC1 to ESC8 in this paper. But after this, there is, multiple other revisions as well, going from within 9 to 15. So we have around 15 different, attack techniques just focused on Active Directory certificate services. And some of these are very critical in a way that it is just going to take 5-10 minutes, not even 10 minutes. It's just going to take 5 minutes to be able to compromise the whole domain. So this is where, the criticality of Active Directory really shines. So we know that we will not be able to prevent our whole environment from having, from not having any single vulnerability. But a single vulnerability compromise or a single user compromise, if it can lead to your whole organization compromise in less than just 5 minutes, how critical Active Directory is going to be. So that is where, Active Directory certificate services or Active Directory security in general is very, very important. So we'll touch upon one of the vulnerabilities from this list, which is ESC1. The interesting part about ESC1 is that it again. So this is going to be slightly interesting, wherein there are a lot of vendor documentation that asks us to configure certain items in certain way, asks us to introduce this vulnerability in the environment. So this is a
Why
research,
so?
So my assumption, they don't understand this vulnerability. So this vulnerability, as we spoke about, it got popular 5 years back. So there is no awareness of this particular vulnerability, before 5 years. And this is going to be making it a lot easier for certificate issuance. So they've gone with the easier approach by not understanding the implications of it. And now if somebody is following, certain official documentation from very reputed vendors, they're going to be introducing vulnerability into the environment.
Wonderful.
So, and this is posted again by the person debugger who's, I think his name is Hoika. So he just listed down some of the official documentation that asks us to introduce this vulnerability.
Wonderful.
So active directory security is becoming tricky because there is a wide variety of vulnerabilities, and unless or until you know what is the specific impact, you don't even know whether you're introducing it or not. So we'll try and cover this vulnerability both from a configuration perspective and also from an exploitation perspective. So let me go into the VM now. So if I go into the VM, I'm going to log into the actual server and walk you through a specific configuration, right? So certificate authority. So let's understand how certificates or certificate authority plays a role in Active Directory, right? So when we talk about Active Directory, we know that user has passwords. That is what we were discussing. And the password is the one that is used for authentication, right? And we're aware of this. So in addition to using password as an authentication mechanism, Windows supports using certificates for, so Windows supports certificates for authentication mechanism as well. So meaning you can be issued by a certificate. So a username can be issued with a certificate, or a machine can be issued with a certificate, and you can present this certificate instead of your password for you to be authenticated in an environment. Okay. So this is commonly used in a lot of Wi-Fi deployments, right? So when you want to allow a user into your network, instead of asking them to enter the password, you're going to be issuing a certificate, and the certificate is going to be authenticating to the network for you to get into the network. So NAC solutions a lot of times use certificates as well. So there are a lot of use cases for certificate issuance. And if this certificate issuance is configured insecurely, is where the problem is. So this is the certificate authority. So it is going to have a lot of templates. If I go into manage, so the list of certificate templates that are visible here are the ones that are enabled. So whatever certificate templates are enabled is going to be displayed here, and there are going to be more certificates that are actually available but may not be enabled. So let's look at, whenever I want to create a new certificate, what I'll do is I'm just going to be duplicating this. So this is for the certificate template. And then in the subject name, by default, this is going to be configured with build from Active Directory. Meaning, if I'm user Siva and I'm asking for a certificate on this template, it is going to be taking my details and then it is going to be providing me the certificate. But the documentation that we talked about, what it is going to do is it is going to ask us to enable a mechanism called supply in the request. So supply in the request, what it means is, for you to have a certificate, the certificate needs to be associated with the name, right? True. So you Subject can tell required. Me, yeah. So you can tell me whose name should be on the certificate. So this is exactly what this means. So basically what I can do is I can go to my Active Directory and say that I need a certificate with Prabh's name. And then it's going to allow me to do. So this one single problem is where, the huge security flaw lies. So if anybody can go to the Active Directory and ask for anybody else's name certificate and allowing them to use that certificate to authenticate as the person is where the problem is. So if supply in the request is enabled, which is what ESC1, and then there are going to be a couple of other, parameters. One is from an extension. So every certificate has different purposes. So one of the purposes is what we talked about is client authentication. So
Okay.
if I, as a user, I want to authenticate to Active Directory, there is a mechanism called client authentication. I can use the same certificate for BitLocker encryption. So there are different use cases for a certificate. So in this case, if you look at application policy, by default, client authentication is going to be enabled. So, and if you look at the security, by default, domain users are going to be allowed to enroll into the certificate. So just by clicking this one single tick and then, creating the certificate, your domain is going to be compromised in less than 5 minutes. So that is how simple it is to introduce this.
It's like a certificate spoofing
vulnerability.
then, no? We can say certificate spoofing, kind of.
Yes.
Or
That's,
certificate
yeah,
manipulation.
we can call it spoofing. Yeah. So we can call it spoofing. Only difference is that I'm not trying to, create something of my own. The authorized person itself is allowing me to, get another person's certificate.
Okay.
So in this case, certificate authority is going to be allowing me to, request certificate on anybody else's name and then use it for authentication. So this is called ESC1. So now we know how it is actually configured. Let's go back to our Kali and see how we can, exploit it. So if I go back to Kali, and so there are multiple tools allowing us to exploit this. So the one that we're going to use is called Certify AD. So Certify is the tool that we're going to use. So what we'll do, we need to start with understanding whether this is vulnerable or not, right? So that is where we'll start. Just 1 second. Yeah. So what we'll do is we're going to start with seeing what are the certificates that are published and what are actually vulnerable. So for that, I'll go into Certify OP and remove everything. Yes. So what I'll do is I'm just going to be using a tool called Certify. So what this tool is basically going to do is it is going to go to my Active Directory environment to see if there is any certificate authority published. And then it is going to be enumerating all the certificate templates that have been published to see if there are any vulnerabilities in them. Right? So what are the things that I've configured? I know the DC IP address I've configured. I know the DNS IP address I've configured. Username, Carlton Drogo, horse, the same password that we compromised initially. So that is the only information that is required for this, right? So with this, if I run this, so it is going to be enumerating all the certificates and then it is going to be giving a nice output. So just gonna, so this is the, detailed output that is given. So let's step through some of the items and then we'll talk about the vulnerability. So CA name. So right now we have a certificate authority configured in our Active Directory. And this is the server in which it is hosted. And then what it is going to do is it is going to go into the specific certificates that are enabled. So these are about the certificate server. So if you go down, you're going to have a lot of information, what vulnerabilities are there. So I'll go towards the last because I know this is where the ESC1 is. So if you look at the template name, so this is basically the name of the certificate template. I've created something called sample vulnerable template, right? So this is the name of the template. And if you look at this flag here, it says that ESC1 vulnerability exists in this particular certificate template. What is the reason? Enrollee supply subject is configured and it allows client authentication. So these are the two parameters that are required for a certificate to be vulnerable. And this is going to be displayed on the top as well. If you look at the certificate name flag, it says that enrollee supply subject. So, and it also has the usage of client authentication. So now what I can do is I can use this certificate template to request for somebody else's name, a certificate, and then use it for authentication. So who else can we use? Literally anybody else, in the domain as well. So what I'll do, I'll just go to my BloodHound, and then I'll do a find all domain admins here, and then let's take this user. So Daenerys Targaryen is the domain admin in my environment, right? So I'm going to be using this user account and then his ID to request for a certificate. So what I'll do is just gonna go back. So if you look at my command here, so certify AD, I'm just going to be requesting a certificate to this TCI address, my username, my password. Bravos is the CA server. This is the CA name. Template here, it talks about sample vulnerable template, which is where I know ESC1 exists. And then the name is going to be Daenerys Targaryen, because I know this is the guy who has domain admin, and then his ID, which is again, accessible from BloodHound. It is not a confidential information. So with this, now I'll be able to request for a certificate on his name, and then the certificate is available now. So now, using the certificate, I'll be able to authenticate as the domain administrator. I'm a normal user, but just one command gave me a certificate of domain administrators, and now I'll be able to do everything what a domain administrator can do. So one other interesting thing that is tied to certificate authentication. We talked about NT hashes, right? NT hashes is the most secret information that is going to be available in NTDS.dit, and nobody will be able to access it unless you attack it. When you are using certificate-based authentication, Windows actually allows a mechanism for you to retrieve the NT hash directly. And this is a technique called unpack the hash. So if you're using certificate-based authentication, I can go to a domain controller and ask him for what is my hash, and then he's going to spit it out to me. So that is exactly what we're going to do for this domain administrator now. So I'm going to be authenticating using the certificate, which I just got, to the DCIP. And if you see here, it is saying it has got the hash for Daenerys Targaryen, and this is the NT hash. So this is one of the mechanisms called unpack the hash, which is going to allow you to read the hashes, just by that. So you don't have to do mimikatz, you don't have to do anything. You just go and ask the domain controller, I'm presenting you this certificate, I need my hash, and it is just going to spit out. So now we have the NT hash of the domain administrator. So again, I can pass the hash and do anything I want in the environment. So if you look at the time it took, it is not even 5 minutes. It's just going to be a couple of minutes for me to understand the vulnerability and exploit it. And this is one of the commonly exploited vulnerabilities in organizations as well. A lot of adversaries are using this vulnerability to just escalate to the domain admin in few minutes. So last part for this section, what I would want to do is we'll also talk about something called DCSync. So DCSync is a mechanism that is allowing different domain controllers to sync data between them. So I have one domain controller in one of the locations, and I have another domain controller. If a new user is created in one of the domain controllers, it needs to be aware by the other domain controller as well, right? So there is a mechanism for them to sync the data between them. True. So this is allowed only for privileged users like domain controllers or domain administrators. Now that I have the domain administrator password, what I can do is I can talk to a domain controller and then ask it to reveal sensitive information to me again. So what we'll do, we'll try and get the KRB-TGT hash from the domain controller using secret stem. So secret stem is the tool I'm going to use. I'm asking for a user account called KRB-TGT.
Precise, yeah.
Yes. So I have the IP address of the domain controller. I have the hash, which we just got. And then I'm talking to the issues.local domain controller IP address. So now with this, I'm just going to be grabbing the KRB-TGT hash of the domain, which is the most sensitive hash the domain is going to have through DCSync. So DCSync is a mechanism that is allowed for domain controllers and domain administrators to sync data between them. But the moment you get a domain administrator or domain controller hash, you will be able to start revealing sensitive information from the DCs. So this is, and we can, similar to what we did with, the NTDS, I can also, yes, similar to what we did with NTDS, I can also ask him to dump the whole users domains as well. So that is also going to be possible. So now I've dumped the complete list of users and the domain using DCSync. So DCSync again is a mechanism that is very noisy, right? So because DCSync is supposed to happen only between the domain controllers, you need to keep monitoring to see if DCSync is being invoked by a non-domain controller. So if you see this in your environment, then it's a huge red flag that something's going wrong. So this section, as we talked about, it just took like 5-10 minutes for us to go from a normal user call Drogo to a complete domain compromise, and all thanks to our vulnerability in the Active Directory certificate services.
But now it is patched, right?
This is a configuration related vulnerability.
Okay.
So domain administrator, if they accidentally introduce it, it is possible.
But have you seen like a lot of companies does this? Like they yeah, okay. And that's why the people like you are there who are using this opportunity.
So
that's why we say hacking is not about using a right tool. It's all about using a right method.
Knowledge. Yes, exactly.
Because if you just rely on the tool, you're a script kiddie. But if you rely on the thought process, then no one can replace you.
Yes. So this, although seems very simple, is one of the commonly abused mechanism both by attackers and pen testers. Like pretty much all of my friends, I have my friends, who's working in consulting in India. They've used this simple attack in top companies in India, like top 50 companies in India as well. They had this. Not because they don't want to secure, but the awareness of these kind of vulnerabilities are extremely narrow with pen testers or specialized things. That is where it gets tricky. So it is a very common vulnerability that you can find.
And please, it's a disclaimer. This podcast is only for education purpose.
Of course. Yeah, I think that's very important. So with this, we have concluded on the Active Directory certificate services, but Active Directory certificate services has a lot of such vulnerabilities, which is going to be extremely easy to, exploit, but commonly reintroduced in the environment, and then can, cause a massive damage. So there are a lot of such vulnerabilities in Active Directory certificate services. And when it comes to DCSync, the mechanism that we use to extract the data out of the domain controller, one of the important things that an organization should have is called MDI, Microsoft Defender for Identity. So this is a specific sensor that is installed on the domain controllers and monitored through, Defender Cloud. So it will be able to pick up these kind of Active Directory specific attacks. So in terms of DCSync, etc., it is going to be very helpful for us to have it. And not having MDI is a significant disadvantage for defenders. So a lot of these attacks is going to, go unnoticed. So MDI is going to be the way in which we will be able to at least detect, if not prevent, all of the vulnerabilities.
Excellent.
So going back to our slide. So now we are almost halfway there, right? So we've covered DCSync, MDI, and Active Directory certificates. So we have a few things. Probably I'll try to speed things up a bit so that, we will try and cover things. Okay, so we are going to discuss about DACL, yeah? Yes. So we just, completed the DCSync part. So DCSync is, as we were discussing, is a mechanism where we can extract all of the sensitive information from the domain controller in a legitimate manner. So it is supposed to do it. It is just because we are having that privileges, we are able to extract all of the user's password. So DCSync is a very, very impactful mechanism where you'll be able to lose all the passwords, right? So next we'll talk about quickly on DACL. So before we go to DACL, I just want to, clarify one of the questions that you raised, right? So whether this is a vulnerability that can be patched. So I know I answered this. Just wanted to add a couple more thoughts into this. When it comes to Active Directory or even, vulnerabilities in the broader space, we have an extremely good focus or at least visibility when it comes to vulnerabilities that are CVEs. All the vulnerabilities that are, patchable. So what we do is we have some scanners that runs on it. And then if we are not able to patch all the vulnerabilities, at least we have visibility in what the critical vulnerabilities are. The things that, usually fly under the radar are these kind of vulnerabilities, which is not associated with any sorts of, CVEs, but is going to be identified through specific techniques or knowledge. This is where a lot of times weaknesses are extremely higher. right?
Okay.
So, and when it comes to actual pen testers or adversaries for that matter, they a lot of times focus on these kind of vulnerabilities which fly under the radar. So it is for me, I personally, I think it is going to be our awareness problem. So one of the things that we are having right now is raising awareness with everybody, right? So similarly, a lot of people need to talk about vulnerabilities, not just pen testers, people beyond the pen testing realm. They need to talk about vulnerabilities, understand the vulnerabilities. If we start doing that, I think we're going to be in a far better shape, as a community. So with that said, we'll jump into DACL. DACL is again a very similar vulnerability where it is not related to any CVEs. This is introduced by misconfigurations. So for us to understand DACL, what we'll do, we'll just quickly go back to our screen on Kali so that we will be able to understand it. So when it comes to Windows, Windows environments, we have primarily two kinds of ACLs. So one is called DACL, which is the discretionary access control list, and the other one is called SACL. So these are broadly the two ACLs that we have in Windows. DACLs are the one that gives you with permissions. So what I can do is, if you look at any organization for that matter, there's going to be a help desk which is who is allowed to change password of other users, right? So it's given with this permission. How is this going to be configured? Through DACLs. So DACLs are the ones that allows us to assign permissions within the Active Directory environment through objects. So this is DACL, and SACL doesn't give us permissions, but it is related to monitoring. So SACL are going to be configured with rules. Let's say if a person's specific attribute changes, I need to generate logs. If this needs to be configured, then we configure it through SACLs. So DACLs and SACLs are the two ACLs. What we are looking at right now is going to be on the DACLs because that is what can introduce vulnerabilities. So we'll go back to our, Karl Droga as the user because, this is the user that we've compromised. And in BloodHound, where we'll be able to see these DACLs are going to be through object controls. So in the object control, outbound object control means what Karl Droga as a user will be able to do. And then
we are escalating privilege also.
Yes. I'm sorry, what was that?
We are escalating a privilege also.
Yes, that's correct. So if we are going to be given with DACL privileges to other users or objects, basically we'll be able to perform action on them and then essentially escalate the privileges. So this is going to be on the outbound. When it says inbound, what kind of privileges somebody has on me? So these are the two directions that we have. So what I can do is going to be outbound. What others can do on this account is going to be inbound. So we're going to be talking about outbound here because we have Karl Droga users compromised. We just need to understand what else we can do from here. So if I go into first degree object control, so I think I have the wrong user selected. It is Denarius Targaryen. Just 1 second. Great. So what we were discussing is on the ACLs, right? So when it comes to ACLs, what I was talking about right now is on two types of ACLs. So one is going to be on the outbound ACL, and then the other one is going to be on the inbound ACL. So when we talk about a particular user, what outbound ACL means is that what are the actions that Karl Droga as a user can do on other objects. So this is basically outbound. And inbound control rates are going to be what can be done to this particular user. Since we have compromised Karl Droga user, what we'll be interested in is, okay, this user, what other privileges that we have. For us to do that, we're going to be checking on outbound object control. So what it says is Karl Droga, I know it's a little smaller here, but Karl Droga, what he has is he has a permission called generic all on the user Viserys Targaryen. So this is the outbound. So this guy Karl Droga has a permission called generic call, which is an ACL on this Viserys Targaryen. So like these, we have different ACLs with different, actions that can be done. So what I'll do, I'll just take a pause here and then point to a good resource that is available for us to understand ACLs. So if I go back to the other screen, so this is again a public resource that we pen testers typically use. So what it has is it has the details of different ACL permissions that are abusable. So generic all is one of the permissions. We have something called write DACL, we have generic write, and we have write property. So there are different ACLs that are available, and what can we do with it from an attack perspective. So this is available, from a publicly available standpoint, where we can use it for pen testing as well. So in this case, what we have is generic all, which is going to be basically generic write. So this is the permission that Karl Drogo has on Viserys Targaryen. So with this, what it means is, we talked about active directory, right? So we have a user object. What generic all allows is, I'll be able to modify any attribute of that user. If I want to change his name, I'm going to be able to do it. If I have to change his password, I'm going to be able to do it. Any sorts of attribute of that user is something that I'll be able to completely change. This is what generic all as a permission is going to be, relevant to. So if you look at it, if I can change the password of him now, yes, I'll be able to do that as well. So one of the challenges that we have in actual pen testing scenarios is, if let's say I have the generic all permissions on a domain administrator, even though technically I can change his password, doing so is going to cause problem to operations. So this is something that we will not be doing. So we will look for other ways in which we will be able to leverage the permissions. But now if you look at it, changing password, so force change password. So this is going to be one of the permissions that is part of generic call. And if we look at the same thing from the administrator's view, so I'll just go back to the domain controller so that we can practically see what this configuration is. So if I go back to my domain controller and go into Active Directory, users, and then the user that we are talking about is Viserys Targaryen. I go into properties, I go into security, and there is this user, Karl Drogo. So Karl Drogo, okay, let me take a step back. So we are talking about the user Viserys Targaryen. So the permissions of Viserys Targaryen is what is displayed here. And one of the permissions is that Karl Drogo has full control on Viserys Targaryen. So this is essentially what generic all means. If you look at the permissions here, it talks about read, write, create child objects. Everything is checked here. And this is exactly what generic all is. So a lot of times what people will do is, when it comes to, giving these kind of permissions, if somebody is giving a permission at the domain level. So this is for the whole domain, right? If I go to the properties here and within security, if I'm going to be giving authenticated users full control, means that even though if I'm not the domain administrator, I can pretty much do everything a domain administrator can do. And these are specific ACLs that we will have to enumerate, and only then we will be able to understand it. It is not going to be showing in groups. Unless or until you specifically investigate the ACLs, you will not be able to understand this. And this is one place where, again, in reality, there is going to be a lot of misconfigurations. So, again, as a meme, if you go through LinkedIn comments as well, what is the easiest pen test that anybody has done? There are going to be scenarios where the everyone group is given generic call at the domain level, meaning anybody will be able to bring down the whole domain if they want. And these are just ACLs. So again, this comes under the realm of not a CVE, but extremely critical, usually missed out. So now that we have this, what is it that I'll be able to do? As I mentioned earlier, one thing that we can do is that I can change the password and then I'll be able to get access to the system. But that is something that is typically not allowed as a part of the pen test engagements. So we're not going to be doing that. What else? So one of the mechanisms that we can do is called shadow credentials. I'll just share my screen back again to Kali to explain shadow credentials. Right? So if I go back to my Kali machine, just one second. Yeah. So I'll just open this. So user account has multiple attributes. As we know, one of this is called as password attribute. There is a specific attribute called MSDS key credential link. So this attribute was introduced when Windows Hello for Business was launched. You remember, right? So we will be able to use pins our
Yes.
face IDs, all those things to log in. So when they brought this, is where this specific attribute was introduced. So even from a pen tester perspective, I was very surprised. How are we allowing small pins to be passwords? But the actual nuance of it is extremely interesting. So the password is not going to be the authentication material. What they do instead is password is going to be used to access a private key pair which is stored within PPM. So trusted platform module is within Windows, as you're aware, is where a lot of keys are going to be stored. So this password is going to be used to access the private key that is going to be within the TPM and use that private key to authenticate in the Active Directory. So this is how this whole Windows Hello for Business is set up. So for this, how the Active Directory authentication works is a user, if Siva is a user, there is going to be an attribute where the public key can be stored, so that if the user comes with the private key, he'll be able to authenticate. But now, in this case, how we can abuse is, if I have write permissions on any user, I will be generating a private key public key pair. I'll put the public key into the attribute of MSDS credential of the other user, and I'm going to use this private key. Now this private key is going to be used to authenticate as that particular user. So this is how, without changing the password, I will still be able to authenticate as that particular user. And this is exactly what shadow credential means. So just to summarize, right? So Windows Hello for Business brought in a functionality, so which allows user to authenticate that does not require user's password. So the actual password, exactly. So you don't need the password. It is just going to be PIN or FIDO keys or fingerprint. You don't even have to remember the password. That is allowed. So how they are doing it? By safely generating a public key, private key, a public key and private key pair, storing the public key within the user's attribute, and using this private key for the authentication. So if somebody else is able to store this public key in anybody else's user account, then this private key is similar to their password. Even if the user changes his password, I will still be able to authenticate as the particular user. So it gives me persistence. So even if the account is compromised and if the user's password has been changed, I will still have access on the user's password. And this is exactly what shadow credentials is. So what we're going to do is we're going to be using the same mechanism to use this access that I have. So Caldrogo basically has generic call in the Viserious target, meaning I will be able to modify all of the attributes.
Can you zoom it a little bit?
Yes.
Yeah.
But unfortunately, the name may not.
That's fine. That's
so
fine.
Okay. So Caldrogo has generic call in Viserious target, meaning I will be able to modify all of his attributes. I'm just going to be generating a key pair, storing the public key on this. Since the stored public keys, private key is with me, I can authenticate as this user. This is exactly what shadow credentials is, and I'm not touching the password at all. So again, there are multiple tools for us to be able to do this. I'm just going to be using the same Certify that I talked about earlier. Certify also has a module for shadow credentials. So I'm just going to be using the Certify module. So Certify, I'm mentioning shadow as the option. The IP address is this, Caldrogo user, Caldrogo's password. What I'm saying, I'm pointing out the account for Viserious Targaryen here. Sorry. So I'm pointing out the account as Viserious Targaryen here, and then auto basically means that it is going to be generating the key pair for me, storing it, getting the hash, and then coming back again. So if you see here, it is saying that it is generating a certificate. Basically, it is generating a public key, private key pair, and then it is generating the key credential, which needs to be added. So device ID is basically, the Windows Hello for Business mechanism. It is going to be added to this user. So once I add this to the user, I'll be able to authenticate as this user. So I'm going to be authenticating as the user with the private key now I have. And if you remember earlier, whenever we are using certificates for authentication, what I can do, I can get the hash, right? So I'm basically getting his hash and then, removing the key credential that I added. So now if somebody looks at the user account, there's not going to be any key credential link, but I've added it, I've got this hash, I removed it, but now I have the user's hash. So all this without touching his password. So I've not touched this password at all. Because I have this access, generic call access on this particular user, now I will be able to authenticate as this particular user. So similarly, when we talk about DACLs, there are so many different abuses that are there. We're just discussing on one access, which is going to be on generic call, and a subset of is generic write. So now I have this particular user, right? So I've compromised Viserys Targaryen as well. What next? We'll go back to BloodHound again. Okay, I've compromised Viserys Targaryen. Does this guy have any other access? So I think I'm still at call through. I'm sorry. Viserys Targaryen, and I'm gonna go into outbound object control. So Viserys Targaryen, what he has is he has generic write. So generic all means I'll be able to read everything as well and write. So which is what generic all is. Generic write means I'll be able to write everything. So even in this case, the same attack that we discussed is still going to be possible. Since I'll be able to write every attribute of his, I'll be able to write the key credential as well and then compromise this user as well. So let's just see how this is going to be possible. It is not very different. It is going to be very similar. So certify AD, DCIP. Now the user account I'm talking about is Viserys Targaryen. I'm going to be authenticating as Viserys using the hash which I just got, right? I'm doing a pass the hash attack, and I now need to compromise the other user who is Jorah.Mormont, right? So now if I go ahead and do this, it is going to work the exact same way like it worked earlier. Since I have a write permissions on another user, which is complete generic write permissions, I'll be able to add the key credential to the same stuffs and then compromise this user as well. So now I've compromised this user. Now let's go back to BloodHound and try and see what is the kind of access this guy has, which is Jorah.Mormont. And I'm going to talk about outbound object control again. So this guy has a permission called read labs password. So read labs password is also another ACL. But before we go into read labs password, let's take a quick detour on what labs is, right? Because this is again one of the most important aspects when it comes to Active Directory again. So all of the devices that are part of the domain, they're going to have passwords, user account passwords, which is tied to the domain, which we all know. So if, for example, Siva, I'm going to be having an account on the domain. In addition to that, every device need to have a local administrator password, which is not tied to a domain, right? So the device itself should have a local administrator password, which is which is going to be useful when if I'm not able to reach the domain, if they still need to make any changes. In all these cases, a local administrator password is going to be helpful. So the challenge with local administrator password is that if I am managing a server of 500 server, for example, or 1,000 workstation, how can I track this local administrator password? This is not something that you will be able to change from Active Directory. So previously, what people used to do is they used to have one image that they use for building all the servers. What it also means is the local admin password of all the servers is exactly the same. So what is the problem? A compromise of one single server will lead to compromise of the entire ecosystem because it all had the same local admin passwords. This is still one of the biggest risks and biggest ways where a compromise of one server can lead to a compromise of entire servers. So how can we address this? Microsoft themselves came up with a solution called local administrator password solution, which is what LAPS is. So what LAPS does is, if you're going to be enabling LAPS on all the servers, the server in a periodic manner is going to automatically reset its password and then storing the clear text password in the domain controller. So that every server in the environment is going to have unique local admin password, but it is still going to be, accessible from a domain. So these are local passwords not tied to the domain, but these are going to be stored within the domain. So what this helps us with even if one server is compromised, the local administrator password is going to be different for a different server. So this is one of the most critical controls an organization should have, because if it doesn't have, as we discussed, a compromise of a single public facing server is going to be, leading to a ransomware on the entire environment. So that is the magnitude that we're talking about. So now, if LAPS is implemented, is there a problem? Yes, there could be problems with the ACLs again. So as I was mentioning, LAPS is stored within the Active Directory now. The LAPS password is going to be stored within the Active Directory.
True.
What if somebody unnecessarily gives a read permission to all the LAPS passwords? So this again is a ACL. So whether I will be able to read the LAPS password or not is going to be an ACL, and that is exactly what is shown here. In this case, Joram Ormond as a user have been given with read LAPS password permissions for a particular server here, meaning I will be able to retrieve the clear text password of this server from the Active Directory. Right? So far it's clear, right? So, and this is exactly what we're going to do now. So we have again a different, tool set for this to be able to read the LAPS passwords. So I'll go into PyLabs. So I'm just using a tool called PyLabs. So what I'm saying is I need to get the LAPS password. Who's the user I'm going to authenticate as? It is Joram Ormond. I don't know the password. I'm just going to be, using the hash that I got recently of this user. And then I'm telling that DC IP address is 5.58.12. So when I run this, what it is going to do, it is going to go to the Active Directory, try to fetch the, LAPS password. In this case, I am only given permission to read the Bravo's machine account's local admin password, and I'm able to see the clear text password here.
Wonderful.
Right. So this is what, LAPS, reading LAPS ACL means. So LAPS as a solution is extremely important to have it implemented. But a lot of times, if ACLs around the LAPS is not properly implemented, they will be able to read the clear text password of servers and then, perform additional activities on this.
And it's very important that, when we're talking about the clarity of the domain integration and validation, whatever we have, it's very important how, how we see the perspective. And the reason why I'm asking this, because there's a lot of noise regarding, SSO or AD integrations, but just a basic configuration issue is getting backfire here, right?
Yes, that's right. Which is, which is one of the problems that, we have, I would say. It is tied back to a lot of times awareness, right? So people, they just want things to work, right? So if I'm going to be an IT administrator, I want to, ensure the environment is secure, which is very important, and I'm trying to focusing on it. But if the IT solution itself is not working to begin with, I have a bigger problem. So a lot of times, both in terms of IT or in terms of developers, they're trying to make things work, and they are trying to get some leeway in terms of security controls, which makes things work, but not in a secure manner. And these kind of aspects, unfortunately, the problem is again tied to the awareness, right? So if they are aware that these are going to be causing these big problems, I'm sure they will not be doing it. But this kind of low-level information is understood and identified only during pen testing exercises, which is what the biggest problem is. And pen testing exercises, by the nature of it, is not comprehensive. It's going to be a time-bound activity. People are going to have, 1 week's time or 2 weeks' time. So it is going to be a time-bound activity and a point-in-time activity. So a lot of times, pen testers, we are trying to do it to showcase impact. It is not practical for us to identify all the possible vulnerabilities in an environment. So this is also a challenge that we have. So unless and until we are aware of all these vulnerabilities, make it aware to the administrators in the way it is going to be actionable to them, it is very difficult to not see this in the wild.
Because right now, whatever that we're discussing, it's not about vulnerability, it's a configuration issues. I know it's a kind of vulnerability, but it's all about the mindset that we're building. Yeah.
Agreed. And most of the items that attackers focus on are on these realm. It is not typically a CVE, but things that are usually missed out because nobody focuses on it. So, and the point that you mentioned on SSO, right? So SSO is definitely very useful, but I'll give you a scenario where SSO is actually counterproductive. So a lot of times in these, recently there is a huge, increase in ransomwares that are focusing on virtual environments. So ransomware that are focusing on servers is one thing, but the virtualization infrastructure itself. So if I'm able to get the admin credentials of an ESXi, essentially I have access to all of the servers hosted in ESXi, right? If a domain account is used in ESXi, then a compromise of domain also leads to compromise of the complete ESXi.
True.
So although SSO is very helpful in these kind of scenarios, if somebody has a separate account for ESXi, then we will be able to prevent these kind of attacks as well. So that segregation in terms of accounts in certain cases is going to be very important by not having SSO as well. So it's kind of tricky on where should we do things, and it is always an improving game that we try.
Excellent.
Right. So going back, now we have a local administrator password of one of the servers. What can we do? This is what we discussed earlier as well, right? So when we got the first local administrator, we know that by having local administrator, we will be able to dump the hashes. So it is going to be the similar thing that we can do with the same password as well. So, but in this case, I'm going to be using a local administrator, not a domain one. So secret is dump on this particular IP, which is basically the browser's IP. And I'm going to be copying this password and then pasting it. So since I'm a local administrator on that particular machine, I'll be able to access RAM, and then I'll be able to dump all the passwords. Excuse me. So this is going to be the impact. And when it comes to Active Directory pen testing, what we do is we keep doing these things to get more privileges until we get to the domain administrator. So we keep switching machines, we keep laterally moving to other devices, so that we get to the domain administrator where we need to compromise the whole setup. So this is basically on the DACL as well as the shadow credentials and LAPS. So if we go back to the things that we wanted to discuss, we've come a long way until LAPS and shadow credentials. So the last thing that we are going to address is on the Kerberos. And I'm sure that Kerberos is going to be one of the difficult areas for anybody to understand. I still remember the first time that I looked at Kerberos. It is one of the complicated things, like why is it so complicated? So we'll try to simplify Kerberos in a manner that it is going to be easy to understand. And by understanding Kerberos, we should also be able to understand why the vulnerabilities exist that are related to Kerberos. Related to Kerberoasting or golden ticket, why does these exist is something we should be able to understand by understanding Kerberos. So that is what we'll try and target next. So yeah, let's talk Kerberos. So Kerberos is going to have three major components in its whole flow. One is going to be the client. When I say client here, most of the times I'm going to be referring to the user. For example, it could be Siva. So where Siva knows his own password. So that is one. And then we're going to have something called as KDC or Key Distribution Center. In our case, this is going to be domain controller. And we've already established the fact that a domain controller is going to know everyone's password, right? So domain controller literally is going to be storing everyone's password in terms of hashes. And that is what KDC is going to be. And then we're going to have a service that the user is trying to access to. It could be a file server or any server for that matter. So this is the three major components that is going to be involved within Kerberos. And when it comes to Kerberos, they're trying to achieve a few things. One is they don't want the clear text password to be shared over the network, which is what their key agenda is as well. So let's try and understand how the authentication works in the first step. So Kerberos, at the very first step, is going to be something called as client authentication or ASREC. So AS request. So what the client or the user does is, as a passer of the authentication, he's going to be taking the existing timestamp, and then he's going to be encrypting the timestamp with the user's hash, and then he's going to be putting his name also in the request and then sending it to the KDC. This is basically the first step. I'm taking my password, taking the time, encrypting the time with the password, giving my name as well, and sending it to the KDC.
Okay.
So what the KDC will do is, it is going to look at the name that is mentioned here, right? And then it is going to be looking for this particular name's password, which is stored within the KDC. So domain controller has everybody's password. So whatever name it says is going to be taking that particular name's password that it has, and is going to try to decrypt the timestamp.
Okay.
And if the timestamp is decrypted, it knows that it is coming from the respective user, because only the user and the domain controller are going to know the user's password. So this is what we're establishing. So since it is encrypted from, with the user password, we are establishing the fact that it is coming from user. And this is how, we are having the pre-authentication stage. And as a part of this flow, I've tried to simplify, a lot of things so that it's going to be easier to understand. So there are going to be certain, low-level details that will be missed out. I'm just making it clear that it is going to be not exactly the same. But with this, you'll be able to understand the broader aspect, because Kerberos is very complicated. So, but with this, you'll be able to understand, where the vulnerabilities are and how things work. So now, the Kerberos, the KDC has identified that it is coming from this particular user, and then the user is authenticated. So what I'm going to do is, I'm going to be generating a new key. So this is similar to how, authentication happens in web server as well. So when you go to any sort of website, you're going to be entering your password only once. You're not going to be keep entering it every time, because the server is going to be creating a temporary session key that is going to be tied to the user. And KDC is also going to be something similar. You've authenticated to me, so now you don't have to come back to me with the same password again and again. What we'll do, we'll have a key that we both of us trust to make sure that we are talking to each other, right? So I'm going to be having a temporary key that is generated, but I need this key to be transferred to this user in a safe manner. Nobody else in the network should be able to sniff it. So how can I do it? I'll take this key and I'm going to be encrypting this key with the user's password.
Okay.
Only the user is going to know this password. So if somebody is going to be able to, decrypt it, it is going to be only the user and nobody else can do it. So I'm going to be using this key and encrypting it with the user's key, sending it. That is going to be one part of the response. And then I'm going to be having another response, which is what everybody call it TGT.
Okay.
Ticket granting ticket. So ticket granting ticket is a message that is encrypted by the KDC's key, which is the KRBTGT. So KRBTGT password hash is going to be used to encrypt this ticket, meaning nobody else will be able to decrypt it other than the KDC himself. So KDC is sending back, two information. First information is this shared session key, and then I'm having another information, which I call it TGT, right? So now what the client is going to do, it is going to be able to decrypt this message, because it is encrypted with this password. He's going to be able to decrypt this message and get the session key, and nobody else is going to have the session key. And then he's going to have a TGT, which he can't do anything with. He will not be able to decrypt it now. He's just going to keep the TGT as is. So this is the first step, wherein I have successfully authenticated to the KDC. We both have a session key that we have agreed upon, and I have a TGT. So this is going to be the first step. So for any questions?
No.
Great. So the next step, what I'm going to do is, I need to be able to access a service, right? So what I'll do is, I'm going to be, going ahead again back to the KDC with the TGT that he's, provided. And then I'm going to be mentioning the service that I want to talk to. And again, I'm going to be using my name and timestamp and encrypting it with the session key. So we've established the fact that this red key is something that is only known between the client and the KDC. So if it is encrypted with the red key, the KDC will know that it is only coming from the user, right? So this is where, it gets a bit interesting. So the KDC never actually stores the red key within it. If you looked at this step, it has sent the red key along with the, TGT. So it knows that this cannot be decrypted by anybody. I'm giving you two items. One is something that you can open up. One is something for my reference later on. So when this comes back now, there is going to be a red key, right? Which I don't know yet. What I will do is I'm going to be using this TGT, which is with my key, and decrypt it. So when I decrypt this, I'm going to have the red key and then other details as well. And I'm going to take this red key now, which is the session key, and try to unlock it. So I've used my own key to unlock the TGT to get the session. And with the session key, if I'm able to open, then it means that only I know this, key. Yeah. So this is how this is establishing the fact that this is coming from the right user. So first time we had the green, which is sent out. Now I'm relying on the yellow, which is the the KRB TGT. Now on, I'm not going to be using this yellow as well. So now I'm going to be creating a similar session key for the service. So I'm going to be creating a blue key now, which I'm going to be sending to the user by encrypting with the session key that we are agreed upon, right? And then this is going to be encrypted with the server's key. So this message that is there in a slightly pink red, this is encrypted in a way only this guy can open it. It is encrypted with his key. So now what I'll do, I'm going to be getting this new session, and then again I'm going to take the same message, and then I'm going to be using the session key that is used. He's going to also decrypt it. Okay, I'm able to decrypt it with my own key, meaning this could have been come only from the KDC. Nobody else knows this key. So I'm decrypting it with my own key, which means KDC has sent it, which I trust. And then there is an information within which I also trust. I'm going to be decrypting this with the blue key. Then this is coming from the client only. So this is how we are trying to establish trust between the servers. And lastly, what I'm going to do is I'm just going to use the same key to encrypt and send it back to say that he has gotten access.
Okay.
So by playing with different keys, so basically we have a total of 5 keys. 3 keys are something that is tied to the user accounts or the service. So the green one is tied to the user, gold is going to be tied to the KRB TGT, and then silver is going to be with the service account. So we have 3 static hashes. In addition to that, we are creating 2 temporary keys through which we are establishing mutual trust between them and then authenticating. So this is exactly how Kerberos establishes trust. Right? So we have the first step called authentication. Second thing is going to be on the service, and the third aspect is going to be on the actual service.
Actual server.
Right? So now that we have a clear understanding of how this works, let's try and dissect where can vulnerabilities occur. Let's look at this step. So this step, the client is saying that he's so and so, right? Which is encrypted with the red key, which is random, which he doesn't know, which is trusted based on this golden key. So forget about the step 1 and step 2. If I know this golden key, in this step, what I can do is I can put any client here. I can even say that it is an administrator. And here also I can put any client, and then I can use one random red key in both the places and send it out. So what you'll do, the trust at this step is only established because this golden key is not known by anybody. But the moment this golden key is going to be known by anybody else, he will be able to impersonate anybody he wants. Right?
That's true.
So
That's true.
This is exactly what we call as golden ticket. So if I have this particular key, which is what KDC puts the entire trust on, then I can use this key to tamper with any other information the KDC is still going to trust. So similarly,
because he already authenticated.
Exactly. So this step is not going to be relevant at all. So if I just go ahead with this particular step, saying that this is the session key that we already agreed upon, you just have to trust it because it is coming with this golden key. So this is how there are structural vulnerabilities within Kerberos. Let's step through the other vulnerabilities as well, right? First one is on AS roasting. If you look at this step, I am encrypting the password. I'm encrypting the client tab with this password. This step is called as pre-auth. And in Windows, we have mechanisms to disable it. So for whatever reasons, if you disable pre-auth, what happens is I'm going to be sending a client timestamp and client principal, and then the KDC is going to be sending the password still with the encrypted password. So his assumption is that this password is going to be known only by client, which is valid. But since this ticket is something that anybody will be able to, request, then I will start and try to crack this password to get the user account's password.
Excellent.
So
Okay.
if pre-auth is not enabled for a user, I can request for this step for any user I want. Let's say if none of the user is enabled with this step, the AS, pre-auth, then what I can do is I can just start requesting this AS rep tickets for every user and try to crack it. Since it is encrypted with this green, I'm trying to target this green to understand the password. And this is exactly what AS rep roasting is.
Okay.
So you can ask me the same question. Why can we not do it with the golden ticket as well? It is encrypted with gold as well, right? So why can we not do it golden? Which is a valid question. But the difference is that this password is user set passwords, meaning it can have weak passwords that we can crack. But whenever a password is going to be set for KRB-DGT, it's going to be extremely long, which we will not be able to crack. But otherwise, the same principle applies for this as well as this. Right? So this is what AS rep roasting it. And golden ticket is what we talked about. So if you just look at this particular step, it doesn't have to, have the previous steps even. I can go directly to the KDC saying that, hey, this is the key that we agreed on. And, this is administrator here I'm talking. Give me the access. He's just going to trust it because he's assuming that this key is not known to anybody else.
And it is peer-to-peer, yeah.
Yes. So it is because, I'm talking to him. So this is why golden tickets are going to be successful. And golden ticket attack is a persistent mechanism. Golden ticket is going to be allowing you to impersonate anybody else if you have the KRB-DGT. But you need to have the KRB-DGT first.
Yeah.
So golden ticket is a persistent attack, persistence attack, and not a privilege escalation attack. So with KRB-DGT, I can impersonate anybody is the design. We are just trying to, practically do it by, generating a golden ticket, right?
Okay.
So this is what golden ticket is. And next step is where Kerberoasting is. So any user in the environment can go ahead and request for a service ticket for any service. I can go and request for a service ticket for SQL service. So as long as I'm authorized to access this service, I'm going to be getting a service ticket. If you look at the same thing, in this response, there are two encrypted items. One is with red and one is with silver. This red again, they're going to be generating with long strings. So we will not be able to, crack that red password. So it is going to be in a cryptographically secure manner. So it's going to be long enough. But service passwords are set by users. If somebody, sets a weak password for a service, what I can do is I can request for a service ticket, crack it offline. I just going to take this and then, do it completely in a different place where I'm going to be trying to crack it. And then I'm going to be getting the password of this particular service.
So there's a sequence we do, right? We are doing it in a sequence.
Yeah. Yes. So two steps. One is we're going to be requesting for a service ticket. That is the first one. And the second is we're just going to be cracking it offline. So this is exactly the two steps. And we'll talk about, Kerberoasting in a practical manner in a minute now. So we'll try to do this as well.
Sure.
So this is Kerberoasting. And lastly, silver ticket. So silver ticket, like golden ticket, is going to be a mechanism for us to access the devices which we already have the passwords of. So if I have the password of this particular machine, then I can use the machine's password, which the machine is going to trust to get access on the machine. So I will be able to impersonate as anybody on that particular machine or on that particular service, and which is what silver ticket is. So all these are possible because of the trust points that we establish. In this case, it is based on the KRB-DGT password. And in this case, it is going to be based on the services password. Right? So this is what Kerberos is and where the weaknesses are, which we are commonly exploiting. Right? So last step, what we'll do is we'll just try to simulate the Kerberoasting process and then, see how it is possible. So the steps that you'd ask for, we'll try to do it in our Kali again. We'll do it in our Kali practically, and then we'll, go ahead. So again, in this case, we're going to be using the same user that we already have. So if I look at this is something that we can look at from a BloodHound as well. So we go to BloodHound and then ask to list all Kerberoastable accounts, whatever accounts that has a service principal. So probably it is worth mentioning that as well. So whatever accounts that are explicitly mentioned as services in the Active Directory is what we're going to be, is what we can request service tickets for. So the step where we're going to be getting a service ticket, it has to be, having something called SPN. Service principal name has to be set for the particular service. That's when we're going to be, doing the Kerberoasting attack. Right? Okay. So in this environment, these are the 3 user accounts that are having SPN set. So we will be able to see the SPNs as well. So we click on this user and node info. If you see here, I'm not sure if it's visible, but I don't know how to, expand it as well. So probably I'll put it in the chat. I'll put it in the text. So if I go here, I can't copy it as well as it. Let me see. Okay, I'll show it in the next step. Maybe it's going to be visible. So for us, these are the 3 different SPNs that are there in this particular domain. So what I'll go ahead and do, I'm just going to be requesting for the SPNs as a part of the Kerberoasting process. It's pretty straightforward. So I'm just going to say that get user SPNs. So whatever has service principal names in my domain, go ahead and request for a service ticket. What I'm using the same DC IP address, same, normal user that we already got. I'm using his password. So now if you see, there are, 2 service principals that are available in my environment, which is for the Microsoft SQL service. So this is exactly what a service principal name is. And I've got the, service ticket for this, which I can use for cracking. Okay. So this is exactly the, service ticket, which is encrypted with the services password. So if I try to run a brute force on it, I'm going to be able to get the password if it is weak. So, but in this particular case, I'm not going to immediately run it because if you remember a little while back,
we covered about that
when we were dumping
hash.
Yes. So when we are dumping the local administrator, when we are dumping the SO server using the local administrator password, we had already got the actual password of the service as well. Yeah. And then, since it's a CTF kind of thing, he's explicitly mentioned you will not be Kerberoasting me because this is not a weak password that can be Kerberoasted. So, but ideally what we're going to do is we're going to be taking this, string, and then we can put it through the hashing with the password list, and then you're going to be seeing the password cracked. So just for us to, complete the step, what I will do, I'm just gonna, I think it's already there. Yeah. So what I'll do is I'm just going to create a word list just with this password to validate whether it is cracking or not. Right. So we know the password. We're just validating whether, Kerberoasting works. So I'm going to take this KRB TGT source ticket. I'm gonna put it. So I'm just, using this ticket, and in the word list, I'm just going to keep this one single list to see whether it works. And so I'm back to John again. So John, this curb, ticket, and then we're using this word list where it is just this one single password just to see if it works. I think John is angry. It's a small J. So John, again, with this, curve txt, you're seeing that it is actually cracked. So if I go back and ask him to show.
Because it's a simple password, it was double curve. If it's a alphanumeric and all that, then it will take time.
Yes, probably, I think I did not explain it clearly. So what it did is, in the word list that we generally use for cracking, right? I put the actual password in there.
Okay,
that's why it got cracked.
Okay, yeah.
Just to showcase that, Kerberoasting cracking
that's a dictionary attack, yeah.
Yes. So I did a dictionary attack where I put the password within the dictionary just to showcase that it is going to be cracked. But if I do this with the normal, word list that we are going to use, it is not going to crack.
Yeah.
Yeah. So this password is not going to be accessible. So this is, basically what Kerberoasting is. And the last aspect we'll talk about is on the golden ticket. Again, golden ticket is not a mechanism for us to be able to gain additional access, but rather it is just to
Maintain the access.
use the existing. Exactly. So if somebody is going to be compromising the KRBTGT hash, with this hash they will be able to impersonate any user in the environment. And we previously did a DC sync and we have got the KRBTGT hash. It is just to showcase that it is going to be possible for us to impersonate anybody in the environment. So for us to be able to forge this golden ticket, we need few more information. One of this is called as domain set. So basically, as a part of the request, I need the SIDs. So what I'm going to do is I'm going to request for the SID. So this is the particular domain SID. And now I'm going to be forging the golden ticket. So I'm going to be using a tool called Ticketer. And I'm pasting the hash of KRBTGT here. I'm pasting this domain SID, and then I'm specifying the domain. And what I'm saying is, I'm saying that I need a ticket impersonating the default domain administrator. So this is the default account. So I'm going to say that I need this ticket of him. And then if you look at it, it is going to be requesting, it is going to be, generating this ticket, and then it is successful. So now I'm going to pass this ticket to the domain controller to see if it is accepting this. Now I created a ticket here, and then it is stored in my local machine. So there is a ticket for administrator, which is encrypted using the KRBTGT. Now I'm going to be passing this ticket and try to dump the KRBTGT hash, because KRBTGT hash should be dumped only by domain administrators, right? I'm going to be checking this to see if it works. And as you can see, it is going to work. So KRBTGT passwords are going to be used to forge tickets across any user we want, across any privilege we want, and these tickets can be sent back to the domain controller, and the domain controller is basically going to trust whatever we are saying. And that is what golden ticket is. And as you pointed out, this is a persistence mechanism wherein I already have the KRBTGT hash. The interesting part is not a lot of organization changes the KRBTGT hash frequently. So it is advised to change the KRBTGT passwords at least once a year, so that if you had compromised 1 year back, those are not going to be valid now. But if an organization has never changed the KRBTGT password, even if you had a compromised 5 years back, they will still be able to access your environment. So that is how KRBTGT is going to be supporting in persistence. And the interesting fact about KRBTGT password is it needs to be changed twice. So just by changing it once, the previous password is also going to be active. So you have to change the password twice before your persistence is going to be broken. So it is recommended for organizations to periodically change KRBTGT password twice, at least once a year, so that if there was compromises early on, they will still not have access.
And one more important part is when you're talking about the golden ticket and the validation we're talking about, this has become a very crucial when it comes to if you don't revalidate on a regular basis, it become a crucial to check that, right? Okay.
Exactly. So golden ticket attacks are going to be, common, and I wouldn't say common, but golden ticket as an attack is going to be very possible for us to resurface, right? If there is one compromise, and then the same password can be used in a later time for us to be able to compromise the same environment without any efforts. So that is where it becomes very critical for us to rotate the KRBTGT's passwords.
Okay.
Yeah. So I think that broadly summarizes all the things that I planned for this session. So we started off with having no access into the environment. So we just go back. So we started off with having no access into the environment. We tried to have some initial access. We did some password cracking, tried to move laterally within the environment, understood different areas of misconfigurations and vulnerabilities, ending up with persistence on the golden tickets.
But wow, we started with 0 and getting into the system access. So, but trust me, it is like a 3 hours, right? It is one of the longest podcasts I did. And wow, 2026 started with bang. And guys, those who are watching this podcast, we having a lot of discussion from last 2 months. What should be done? I think Shiva, we have started a discussion from October, November. I think.
Yeah, I think it was November.
Yeah,
I think it was
November.
November.
Yeah,
Yeah, yeah.
and it is worth it. Yes, it is worth it. Thank you, Shiva. This is really, really amazing. And those who really watching this podcast till the last, I'm sure. Um, Let me know your opinion about the next video shall we make on pen testing with Shiva, and I can disturb Shiva again for another podcast. And I can see Shiva, training is something your passion. Otherwise, people will lose the interest after 1 hour, 2 hour. But the way you drive the things, you started with the concept of explaining, then you move to uh, the topic explanation, then attack. Just amazing, Shiva. God bless you, and you are doing a great job.
Thank you so much, Prabh. Thank you so much for having me as well. These kind of topics being able to explain and it reaching wider audience. I'm sure that will help
Definitely.
so many
And
people
Shiva,
to
will you be
understand
open
some
for
of the
another
core concepts
podcast?
in
I
that.
want
Yeah,
to do that, man. Because it took me around
sure,
50 pages to
sure.
make the notes. I was typing, and my God, it was really amazing. It is boom,
Thank you,
to be frank. But
thank you so much,
really,
Prabh.
you made my
Thank you.
day, and it was worth to spend weekend with Shiva on this topic.
Yeah, for me also, I think we started the year with a bang, so
Yeah.
I think it's a good start for the year for a
And the
good
reason
weekend.
of Shiva
So
starting this
thanks.
YouTube channel and with this practical podcast, see, everyone is doing podcasts, but what is
Mm-hmm.
special, why we are doing podcasts in this way is, to give a value, to create an impact
Mm-hmm.
in people mind. And that is the
Right,
reason,
right,
we came with this initiative and all that, to just give more
right.
and more practical insight. I cannot say it is my podcast, it is your podcast. Okay, because you are the one who driving these initiatives. But thanks, Shiva. Thank you for taking out the time
Thank
for
you.
this particular session. And we looking forward to have more sessions from you.
Sure, Prabh. Thank you so much for having me.
Thank you, Shiva. And this is all from our side team. Do let me know how do you find the podcast. And if you're new to the channel, do subscribe to the channel and click on the bell icon to make sure you should not miss the future videos on a similar topic. Along with that, I'm also sharing a profile of Shiva in the YouTube description. If you have any query, you can reach out to him directly for the support. This is all from my side. Thank you so much. Good day. Bye. Thank you, Shiva. Thank you so much.
Thank you so much, Prabh.